All right, welcome in. Hopefully you are all, we are all here, we are all listening, we are all good. Guys, this is the night before these precious kids in this grade 9, okay, they write. So I'm going to be looking at some grade 9 maths, specifically term 3, with a focus on linear functions, okay, linear or straight line graphs if you want to call it that, and then also geometry. Okay, and seeing as though like in this live I am specifically, I think please do share the live with relevant individuals and people I think I just need to share this live with. Yeah, let's share the live to as many people that need to receive it. So yeah, so that we can. Guys, the reason why I'm doing this live is not really for many people. It's for my kids at my school, and that's why I'm live now at this present moment, because they are writing tomorrow and I have no idea what the paper is going to be, because it's not a paper that I have set, but it's been set externally. So we are going to look at a specific paper. This is a paper that I have posted on my TikTok page, but maybe going through it may assist us and help us to unpack some of the concepts that are in the in the syllabus. So let's check this paper and then maybe we can answer it together, right? There's no better way than to answer questions together. Me too, I'm writing. All right, nice, good for you. I'm glad me too, we are writing. So hopefully we can see this first question there. I'm trying to move the actual document around so that we can see it together. So there in question 1, it says 4 options are provided as answers to the following questions. Circle the letter corresponding to the correct answer. Like I said, this is it's already on the question paper with the memos already there, but I just want to go through the paper so that we can unpack certain things. So there it says the equation of a straight line drawn below is, okay, and guys, there is the straight line. If you look at the straight line, it is an increasing gradient straight line, 1.1. Plus, on top of that, what you do see is that it has a y-intercept and an x-intercept. Okay, so if you look at the y-intercept and the x-intercept, the y-intercept is a positive value there. You have the y-intercept being equal to 1 because the graph cuts the y-axis at 1. You can see the 1 there, that's positive. So on the y-axis, the graph is cutting the value of 1 there on the y-axis. Then on the x-axis, the x value that the graph is cutting through there is -1. Okay, now they are asking us to find the equation of this line, and they have options there: option A, option B, option C, and option D. And obviously, when you are asked this question, then you ask yourself, how am I going to know which option to choose? So we need to know how to find the equation of a straight line when we are given the intercepts of that particular function. So immediately when I look at this particular straight line, because it is increasing, I know that the gradient of the straight line is positive. Okay, that's the first thing. Secondly, because the graph cuts the y-axis at 1, I know that the y-intercept is positive 1. In other words, the value of c for my equation of the straight line will be 1. So I'm just going to remove this picture a little bit. Okay, and I know, I like what the person who's saying the answer is B. I know it, I can feel it. You need to know it, you need to feel it, but you must also be able to explain it. Knowing it and feeling it is not enough, but you need to be able to know it, feel it, and explain it. All right, so I want us to look at the option A. If we look at option A, y is equal to x plus 2. Now you can see there that if you're saying y is equal to x plus 2, that means that plus 2, if that was the straight line, then that value of 2 in the equation should be the value that is in the place of the positive 1 on the y-axis. So that means option A is out, because the y-intercept there, the y-intercept for the first equation is actually positive 2. So whereas in the given equation or in the given graph or straight line, the y-intercept is actually positive 1. Okay, if we look at B, okay, let's skip B a little bit. Let's go to option C. Y is equal to 2x minus 1. The y-intercept there is negative 1. So that goes against the function or the graph that we have there, because the y-intercept is positive 1. If we look at D, the y-intercept is positive 2. But in the straight line we have the y-intercept is positive 1. So I'm sure you guys can see that by eliminating the options that have a y-intercept that is not 1, we can clearly see that the only option we are left with has to be B. Because why? In B, the y-intercept is actually positive 1, and it is related to the value that we have there on our y-axis, the value of 1, where the graph passes through. So we have to then say that B is our option. Okay, so Q, Zaiko, and even Utan, you guys are 100% correct. The answer is B. Okay, that is the equation of that line. But I also want to suggest the following, that you could find the equation of the line through working it out. So I'm going to actually just, remove this. If we look at this equation, this line, all right, like I said, there we have what we call the y-intercept. Why do we call this part the y-intercept? Because remember, on the y-axis, that's where x is equal to 0. So the value that we're seeing here is the y value of this point. It is positive 1. Okay, all right, I see. Thank you, Kacheso, for saying that. So this is the y-intercept. That's where we let x equal to 0. If we were to write down the coordinates of the y-intercept, these are the coordinates of the y-intercept. Where x is 0, the y value is 1. Okay, here we have what we call the x-intercept here. This is where the graph cuts the x-axis, the x-intercept. This is where we let y be equal to 0, if that makes sense. So if we write down the point here specifically, this is negative 1 and 0. That is basically the coordinates of that point there. So the coordinates of this point here are 0 and 1, whereas the coordinates of this point there are negative 1 and 0. Okay, I hope that makes sense. Now, to find the equation of a straight line, we know that the standard form of the equation of any straight line is given by y is equal to mx plus c. The m here refers to gradient. The C here refers to the y-intercept. In actual fact, to be more specific, this is the y-coordinate of the y-intercept. That's what we can really say. The C value is the y-coordinate, meaning this positive one. It is the y-coordinate of the y-intercept. That is what the C value is. Okay, so if I then find this specific equation, I can say y is equal to mx. Now in the place of C, I can substitute what? This positive 1, which is the y-coordinate of the coordinates of the y-intercept. So I can say in the place of C, I can say positive 1. Where did I get this positive 1? I got it there where the graph cuts the y-axis, the y-coordinate of the y-intercept, where the actual point itself fully is 0 for x, because here on the y-axis the x value is 0 everywhere on this vertical line, and the y-coordinate at this point is positive 1. So the C value for my equation in standard form, the C value is the y-intercept, and so we write in the place of C positive 1 from there. Then what you can do is you can substitute any point that lies on the line. Any point that lies on the line. Now there's a point that we have, which is this one, that lies on the line. This point is actually -1 for x and 0 for y. This x-intercept, because in the x-intercept, that's where we let y be equal to 0. So the coordinates are -1 and 0. So we can substitute this point, -1 and 0, substitute it into the equation so that we can solve for m. In other words, the gradient. So let's go and substitute. When x is -1 and y is 0, let's go substitute here. In the place of y, we substitute 0 is equal to m into the x is -1 plus the 1. Then from there, we can actually say 0 is equal to, what's m times -1? -m plus 1. Then we take the 1 over to the other side. That becomes -1 is equal to -m. Remember that we can take this positive 1, which is another term in this expression. When it goes over to the left, the sign of the positive 1 changes to negative. Then we can solve for m. -1 is equal to -m. We divide both sides by what? The coefficient of m, which is -1. But what we do on the right, we must do where? On the left. And that leaves us with an answer. M is equal to +1. So all in all, what is the equation of the line that we have just looked at? The equation of the line is y is equal to, in the place of m, we now have what the value of m is. It is 1x and then plus what? Plus 1. This is the equation of the straight line. So if we go back now, go back where now? Go back to where we started. You will remember here that we were wanting to find the equation of this line. The equation of the straight line drawn below is actually b. Indeed, y is equal to x plus 1. Y is equal to what? To x plus 1. Okay, so I'm going to go over this one more time. If we look at this straight line, we have this point 1, which lies on the y-axis. We call this point the y-intercept. -1 here. This is a point that lies on the x-axis. We call this the x-intercept. On the y-intercept, that's where we let x be 0. On this line, everywhere on this line, the x value is 0. Everywhere on this vertical line, because this is the y-axis. So if we want to find out what is the actual coordinates of this point, we know that x is 0, and this here is the y value at this point, which is positive 1. So 0 and 1 is the coordinates. This here is negative 1. It's the x-intercept. So this is where we let y be equal to 0. But our corresponding x value is negative 1. So the point is negative 1 and 0. We want to find the equation of the straight line. This is an increasing straight line. It has got a positive gradient. So we write the equation, the standard form of the equation of the straight line, which is y is equal to mx plus c. What does m stand for? The gradient. What does c stand for? The y-intercept. When we do have the y-intercept, what do we mean by the y-intercept? Where the graph cuts the y-axis. If we have this point, it means we can substitute the c value. What is the c value? It is the value of y for the coordinates of the y-intercept. So this y value here, the y-intercept, is actually the c value for when our equation is in standard form. So I can take this positive 1 and substitute it in the place of c. It becomes positive 1. Then I can now write the equation with the y-intercept. Y is equal to mx plus 1. Where does this 1 come from? It comes from where the graph overlaps the positive 1. Okay, so there it is. C is positive 1. Then, since y is equal to mx plus 1 now, we can take any point on our graph. Specifically, we are going to take this other point, the x-intercept. The coordinates of the x-intercept, remember, this is where we let y be 0. So that means the coordinates are y is 0, we mean we write y being 0. Then the corresponding x value is negative 1. So that means our point is negative 1 and 0. We go and substitute this point in the equation. Remember, x is negative 1, whereas y is 0. So that means in the place of y, I'm going to substitute 0. Where does the 0 come from? It comes from here. In the place of x, I'm going to substitute negative 1. Where does the negative 1 come from? It comes from here. Then when I substitute that 0 and negative 1, what does that allow me to do? It allows me to solve for m. Now I say m times negative 1, that gives me negative m. The plus 1 is there, the 0 is still there. Now I have a chance to solve for m. I take the positive 1 over to the left-hand side, since it's a second term in the expression on the right. Take the positive 1, goes over the equal sign. When it does go over the equal sign, what happens to the positive 1? It changes sign to negative 1, equal to negative m. Then I want the value of m, but this negative sign needs to go. So I divide by whatever the coefficient of m is. In other words, whatever the number is before the m. Okay. Divide by negative 1. I get a value of m, which is positive 1. Because the negative that divided by negative is a positive. So this is positive m. And then negative 1 divided by negative 1 gives me positive 1. So since now I have m, I can now go back to my equation and put the value of m in the place where m was supposed to be. The final answer is y is equal to x which is positive 1x plus 1. And there it is. Okay, so this is how we find the equation of the straight line. So that's why, guys, when we choose the option, we choose the option B, because it is the only option where we can see that there's a y-intercept that is positive 1. Alternatively, some people could have found the equation by using the gradient formula. Remember, guys, after all, that I have this point, which is the coordinates of the y-intercept are 0 and 1. So I can write 0 and 1. And then this point, which is the x-intercept, that's where I let y be 0. So I can write this point, which is negative 1 and 0. Then I can first find the gradient of the equation. So remember, to find the equation of the straight line, I need two things. I need the gradient and I need the y-intercept. So let us start by finding the gradient, because this is another way of finding the equation of the straight line. If we find the gradient first by using 2 points that lie on the line, we can also achieve finding the equation, which is y is equal to x plus 1. So let's check this out and see how we can go about this. I have 2 points. This is 0 and 1, my what? My y-intercept. And this is negative 1 and 0, my x-intercept. This is my first point. So since this is my first point, I'm going to say this is x1, this is y1. Then this is my second point. So I'm going to say this is x2 and y2. This formula is helpful because it helps me get the gradient of the equation of a straight line if I'm given 2 points. So since I have the y-intercept and the x-intercept, let's go. x1, y1, x2, y2. So let's go and substitute now. In the place of y2, I'm going to write 0. There's a minus sign that follows, so I'm going to write that minus sign. In the place of y1, I'm going to write positive 1. So I'm going to substitute and write positive 1. Over x2, I'm going to write negative 1. Write the minus sign of the formula. And then x1, that is 0. Okay. 0 minus 1 at the top. Now I'm going to add and subtract, gives me negative 1 in the numerator. Negative 1 minus 0 gives me negative 1 in the denominator. What's a negative divided by a negative? That is a positive. What is 1 divided by 1? That gives me 1. So that means my gradient is equal to 1. So I can now go on and say y is equal to mx plus c. My m is y is equal to 1x plus c. What do I need now? I need the value of c, because I've found the gradient, which is 1. I need the value of c. So how do I find the value of c? Remember, I said c is our y-intercept. If I have the y-intercept, as you see me here have, that means I can go directly and substitute the value of the y-intercept, which is c. So I just simply say y is equal to x plus the place of c. Remember, whatever the value of the y-intercept is, that means that is the value of c. Remember, by y-intercept we mean where the graph cuts or overlaps the y-axis. So we know that the y value here is positive 1. That is the c value. Okay, and you can just simply write plus 1. Or if you are another learner, you might just say y is equal to x, 1x plus c. Decide to take a point as it is and substitute so that you can solve for c. You can do that too. Okay, if you decide to take a point, let's say you decide to take the y-intercept, by all means, y-intercept, remember the x value is 0, the y value is 1. So where y is 1, x is what? Is 0. So I'm going to substitute 1 into 0 plus c. Then I'm going to solve for the value of c. 1 is equal to 0 plus c. Therefore, 1 is equal to c. My c value, guys, is equal to 1. Then I can conclude and say y is equal to, remember, I had the gradient, which was 1. The gradient was 1. So I'm going to follow the x plus what? Plus the c value, which is 1. So this is a third way of finding the equation of a straight line. If you are given 2 points, you can find the equation by first finding the gradient using the gradient formula, y2 minus y1 over x2 minus x1. Then substituting the points that you have. Please make sure, okay? Please make sure that you assign, okay, the points x1, y1 since this is your first point, x2, y2 since it's your second point. Then you substitute, acknowledging the signs that are in the formula together with the signs that come along with the numbers, and then you get the answer. That's correct. You see this gradient, guys, it is a positive one. It is greater than 0. It means that my straight line should be an increasing straight line. This answer makes sense because look at my straight line. It is an increasing line. So this makes sense that I have a positive 1 because an increasing straight line will always have a positive gradient. And then you substitute into your gradient form, your equation for a straight line, which is the standard form. And then you use a point to find the value of c. Or if you know what the y-intercept is, it's a matter of just simply substituting the c value as positive 1. And that's your equation. Okay. Guys, thank you so much. I hope that makes sense to those who are here. I saw someone called James come into this live session and say the following: yo sir, thanks to you I got a 50 out of 50 in my maths paper too. Oh great, that's beautiful. I'm guessing that's a grade, what is it? Is that a grade 11 or a grade 10 learner? Must be, or grade 9. That's interesting. Good stuff. At least the lives are helping for some people. That's nice. Good for you. Good for you. I can celebrate that. I think I need to screenshot this. Future testimonies, call it what you want. Okay, let's go. Okay, discrete and continuous. All right, simply put, okay, is it Gachiso? Thank you so much. What is it? What did you say your name is again? I remember you said your name earlier on. I'm just trying to figure out, what did you say your name is? Is it Gachiso? I thought you said Gachiso. Gachiso, nice, okay. Discrete and continuous data. Usually they talk about discrete, continuous. Okay. Discrete would mean integers, or maybe naturally more beautifully put would be natural numbers. When we talk about discrete data, you are talking about natural numbers. Natural numbers, what do you know about natural numbers? Natural numbers are numbers that start at 1. They increase by 1 all the way to infinity. All right. So if you are having a graph, this would be discrete data. Okay. It's not. So for instance, this would be a recording 1, and then maybe this is 2, and this is 3. All right. You don't connect the dots with discrete data. With discrete data, you are talking about natural numbers in a sense. né? Natural numbers. Okay, you move from 1, all right? There's nothing in between, to 2. There's nothing in between 2, 3. So like for instance, your dots here would represent that. Okay, but with continuous data, it's like your graphs. For instance, your straight line graph, it's like it connects. Okay, it connects. So that's why we say continuous data, on the other hand, does not refer to natural numbers, but it's more of like real numbers because it's continuous. All right, so we can have numbers in between 1 and 2. We can have 1, 1, 1, 2, 1, 3. We can have every number in between 1 and 2 represented. So that's the difference between discrete and continuous data. Discrete just means that you are moving from, it's like natural numbers, okay? And then when you're talking about continuous, then that's all real numbers, in other words, okay? So it's continuous. It's continuous, whereas discrete is not continuous, okay? All right, guys, I'm going to have to move on to the next question. Let us go and see if we can't now just wait. Okay, let's go back. Okay, look at 1.2. The equation of the graph that passes through the points 3/2 and 0 and 0 and 3 is, okay, once again, the equation of the graph that passes through the points 3/2 and 0 and 0 and 3 is. Okay, so once again, what would we have to do in order to figure this one out? We need to first look at these 2 points and ask ourselves, okay, these 2 points, all right, what is what? What is what? What do we have here? Okay, 3/2 and 0. Which one is the x-intercept? Which one is the y-intercept? You know that you have the x-intercept in one of, one is the x-intercept, and you know the other one is the y-intercept. 3/2 and 0, is that the x-intercept or is it the y-intercept? 3/2 and 0. Okay, so hopefully we can see that 3/2 and 0, since y is equal to 0, when do we let y be equal to 0? We let y be equal to 0 if we are dealing with the x-intercept. So 3/2 and 0 is the x-intercept. Whereas 0 and 3, that represents the coordinates of the, we let x be equal to 0 if we are dealing with the y-intercept. Okay, then if you look at the y-intercept, what did we say about the y-coordinate of the y-intercept? Didn't we say, guys, that the y-coordinate of the y-intercept gives us the c value of the equation when the equation is in standard form? Okay, hopefully we can still remember that that is actually very true. We did say that, didn't we? Okay, and then since that is the case, okay, remember this here, y is equal to mx plus c. Since this is the y-intercept, and this 3, y is equal to mx plus 3. So we need to look which equation in what we have has this y-intercept. Let's go back. Let's go back there, guys. What do you see? Which one? A is y is equal to negative 2x plus 3. B is y is equal to negative 2x minus 3. C is y is equal to negative 3x minus 2. And then D is y is equal to negative 3x plus 2. I'm sure you guys can see which one is the answer there. Okay, so the answer is what? It's A. It has to be A. It has to be A. All right. Okay. Yeah. The answer has to be A because the c value, which is the constant, guys, please, this is the constant in our equation in standard form. Okay, this is the constant. Okay, so it has to be A All right, because what we can do now is we can substitute to this point and just check what m value do we get. I mean, we could confirm this. Okay, so y is equal to mx plus 3. Remember, 3 over 2 and 0, we can substitute 3 over 2 and 0. That's when x, the y value is 0, m into 3 over 2 plus 3. Then we take the 3 over, becomes negative 3. Then we have 3 over 2m. Then the coefficient of m is 3 over 2. So what do we do, guys? We divide both sides by 3 over 2. This cancels. We are left with m is equal to, and remember, when we have negative 3 divided by 3 over 2, okay, we can then solve this, guys. Negative 3, remember the division sign changes to multiply, then we invert the fraction. We write the fraction as a reciprocal. When division changes to multiply, then the 3 over 2 becomes 2 over 3. Hopefully we can remember that from maths earlier on this year. Divide changes to multiply, and that's what happens. Then this 3 and this 3 can cancel. The negative sign though remains, because when they cancel, this is in the numerator, this is in the denominator. 3 divided by 3 gives you 1. So you have negative 1 times 2, which is negative 2. So m is equal to negative 2. So the equation of this line is actually m, we now have is negative 2x plus 3. That is giving a vibes, isn't it? Okay, that is giving a vibes. All right. Okay, now I'm trying to figure out, why doesn't the sign also change? Which sign are you talking about? Why doesn't the sign also change? Which sign? Okay, as I said, y is equal to mx. Why did we write plus 3 there? It's because we could see that the y-intercept, when we let x be equal to 0, the point there, this 0 and 3, is giving us the coordinates of the y-intercept. This 3, when x is 0, this 3 represents our c value, which is the constant that we substitute into the standard form of a straight line function. This 3 needs to be substituted here because it is the c value. That is 3. Then I take this point, okay, I take this point, 3 over 2 and 0, I substitute it into the equation y is equal to mx plus 3. Where does this 3 come from? This 3 comes from the y-intercept. Why am I saying this is the y-intercept, guys? For the y-intercept, we always let x be 0. This here is 0, it's in the place of x. This here is 3, it is in the place of y. The coordinates here represent what we call the y-intercept. This 3 belongs here in the place of c. Why does this 3 belong in the place of c? Because when we let y be 0, this y value represents the constant that is belonging into the equation of a straight line, which is the c value. So that's why in the place of c, we are now substituting who? 3, because this is the c value, the y-intercept of our function. How did I know it's the y-intercept? Because for y-intercept, we always let what? We let x be equal to 0. So the corresponding y value represents the c value that we substitute into the equation of a straight line. So that's why we have c, the 3 in the place of c, and then of course, that's why then I move on and I say, okay, since y is equal to mx, in the place of c, we have 3, which comes from here. Then I can take any of the 2 points, substitute and solve for m, which is what I've done there. Now I'm solving for m, substituting the other point. Remember, this here represents x, this here represents y. I substitute, what's m times 3 over 2? It's 3 over 2m. The plus 3 is already there. I take the plus 3, I transpose it, it becomes negative 3. Okay. Then after that, I divide both sides. This is 3 over 2m. I divide by the 3 over 2. If you divide by 3 over 2 here, you must divide negative 3 also by what? By 3 over 2. This is negative 3, this negative 3 divided by 3 over 2. Okay, but then this division sign, I change it to multiply. Then this fraction becomes 2 over 3. That's what happens when we are dividing. We can change the division to multiplication. This is something you should have learned in grade 7, grade 6. Okay, when you are dealing with division and multiplication of fractions, if you have a division sign, we actually change the division sign to multiply, and then that allows us to write the fraction that follows as an inverse. So 3 over 2, the numerator goes to the denominator and the denominator goes to the numerator. Someone else, if they want to, they could simply use the calculator and just say negative 3 divided by 3 over 2. It will give you the answer just like that. So it's not really like necessary to do the division to multiplication. Then, you know, you can always just say negative 3. Take your calculator, say negative 3 divided by 3 over 2. Okay, we change the division to multiplication. Then what happens to the fraction? 3 over 2 becomes 2 over 3. The sign negative does not change. It's because remember, I took this 3, it went over, it became negative 3. Now I can divide this 3 and this 3 together. 3 divided by 3 gives me 1. Then I'm left with this negative 1 times the 2, which gives me negative 2. So my m value is negative 2. So my equation, y is equal to negative 2x plus 3. This is the equation of the straight line. So if I now go back for the option, the equation of the graph that passes through the points 3 over 2 and 0 and not and 3 is definitely A, no doubt. Okay, let's move on to 1.3. There's some deep things we are learning here, and it's good that we are learning these things, yeah. Okay, 1.3, no problem. The linear graph for the equation y is equal to negative 3x plus 6 is 4. There's a D there. We have a vertical line for D. There is a B there. It's an increasing line. All right. There's a C there. Okay. Which is a solid vertical line. And then there's an A there, which is a decreasing straight line. All right. And then they are asking the question, the linear graph for the equation y is equal to negative 3x plus 6 is 4. Which one? Graph A, the decreasing straight line. Graph B, the increasing straight line. Graph C, the vertical line. Graph the vertical y-axis. Okay, graph D, the vertical straight line. No, I'm not assuming that this will be the paper we're writing tomorrow. Guys, please do not fall into the trap. I am just doing a past paper. The assumption, there's no assumptions that I'm making here. I am just using this paper as a way of being able to help you guys remember some of the concepts you've learned, which can possibly be tested. It's not about the questions themselves that can be tested. It's the concept. Do you understand the concept behind what we are doing? Do you understand the thought process behind getting to what we need to get? That's what's important here. Okay, I'm not playing God or playing magician here. No. Please, yeah. If you are here for that, then you are in the wrong place. Okay. Yeah, no. It will be luck or sheer luck if it happens, you know, because there's lazy people who reproduce the same papers. It will be luck. If it happens for you where you are at, it happens. If it doesn't, it doesn't. You must be in the position of answering any question. So you guys need to allow me, when I'm done with the question, if you have questions about the approach, you must ask me. If you think that this is me trying to predict what the paper will be for you tomorrow, no, then you are in the wrong place, guys. I'm not playing prediction. I'm here to teach, to help you revise and recap on some of the concepts you've learned. The linear graph for the equation Guys, you said A, majority of you said A. So you're saying graph A is a representation. And since you are saying it's graph A, you guys are 100% spot on. Okay, why? Why are you 100% spot on? You are 100% spot on because when the gradient is greater than 0, in other words, when the gradient is positive, in other words, the m value is positive, this is the kind of line you have. That is not the line that you saw in the diagram. Okay, that is, yeah. If the m is less than 0, you are expecting a graph that slopes downwards, that decreases like this. Okay, I think this is what you guys saw on the diagram, and this is the equation that you said is aligned with y is equal to negative 3x plus 6. Okay, I hope you see. So if you said A, okay, understand that because the gradient is negative, you are 100% correct. Okay, that's why you are correct. So we must understand this concept. If the gradient is positive, this is the direction of the straight line. It's an increasing straight line. If the gradient is negative, it's a decreasing straight line. It's sloping downwards. If the gradient is equal to 0, then it is a horizontal straight line. Horizontal, guys, just horizontal. Okay, with a constant y value. In other words, the y value is the same throughout that horizontal line. If it is having a gradient that is undefined, then we have a vertical straight line, meaning our x value is constant throughout that vertical line. This is the only equation, the only straight line that has as its subject x is equal to something. All these three have always a subject y is equal to something. Here the gradient is 0. Y is equal to something. Here the gradient is negative. This kind of straight line shows a negative gradient. Here the gradient is positive. Y is equal to some positive gradient x plus something. So this is what we need to understand. You need to understand this very well. So why did we reject all the other options? Why did we reject graph B? Because graph B is an increasing line. If you look at the equation of the straight line there, okay, it's a negative gradient. So it can't be represented by graph B. Graph C is a vertical line, meaning its x is equal to something. It can't be that one. Graph D is a vertical line. It is x is equal to something. It can't be that one. So that's why we rejected those options and we accept the option of graph A, 100% correct. Guys, what time will I finish? I'll probably finish at 12. So unfortunately, if you have to sleep, go and sleep. If you're going to stand the test of time, stand the test of time. Just for you guys to know as well, I'll sleep at 12. I'll be getting up tomorrow morning at around about 4:30 to do an early morning shift just before people go to school. So yeah, that's just something for you to note. Thank you so much for the rose, Kachi. So by the way, I really appreciate it. I did see that rose. I'm sorry that I did not thank you when you gave it to me, but thank you so much. I really appreciate it. It means a lot. Let's move on to the next question then. There are more questions that are crying for our attention. 1.4. Angles formed from perpendicular lines are. Angles formed from perpendicular lines are. Angles. This is a perpendicular line. Okay, I'm just gonna show you now, guys. Perpendicular line. Right, I just want to move there. You see here, this would be perpendicular. You have that little box there. So they are saying angles formed from perpendicular lines are A, are they acute? Are they acute? B, are they straight angles? By the way, acute angles, what do we know about acute angles? Acute angles are angles that are between 0 and 90. Okay, 0 and 90. Look at Lilita there. Lilita is like, please show those gradient notes. These are the gradient notes, Lilith. All right. You spoke. You took you too long to speak. Gradient is positive, increasing line. Gradient is negative, decreasing line. Gradient is equal to 0, horizontal line. Gradient is undefined, vertical line. Those are the notes, my friend. I hope you're sorted now. Can I go back to my beautiful question, which you saw? Okay, let's come back here, guys. We are together here. Angles formed from perpendicular lines are they acute? In other words, are they between 0 and 90? Between? No ways. Are they straight? In other words, are they equal to 180? Angles formed from perpendicular lines are straight angles. In other words, they are 180 degrees. No. Are they corresponding angles? No. Are they right angles? Yes, guys, they are right angles. Remember, what is a right angle? A right angle is an angle equal to 90 degrees. So if they are talking about perpendicular lines, they are talking about angles, the angles that are formed. Okay, yeah. Okay, I hope that makes sense. Let's move on to the next question. So D is the answer. It can't be all the other options, it's D. 1.5, what is the size? 1.5. We were at 1.4, so we were asking angles from perpendicular lines are A, acute, B, straight angles, C, corresponding, D, right angles. So we've learned that they are right angles. Now let's go to 1.5. What is the size of angle D? Angle D. Is it A, 180 degrees, B, 60 degrees, C, 120 degrees, D, 30 degrees? Okay, so I can see the large majority is saying B. Some people are saying 60. Someone said Bagajuju. I'm guessing they're saying Bagajuju because Bagajuju starts with B. Okay, that's fine. B for Bagajuju. It seems like we have avid all Pirate supporters here. They don't mess around. So guys, D is 60 degrees, and Molimo Mutawung says vertically opposite angles. So hopefully we know that when two lines intersect, two straight lines intersect, they form vertically opposite angles, and we know that vertically opposite angles are what? They are equal. So if that 60 degrees is there, vertically opposite to angle D, then we know that angle D is 60 degrees. So 1.5 is 60 degrees, meaning it's option B. Very good. Let's go on to 1.6. If AB is parallel to CD, then X is equal to AB is parallel. Let's zoom into this. AB is parallel to CD, then X is equal to 140 degrees, B 100 degrees, C 40 degrees, D 180 degrees. Okay, now lot of differing options and opinions. I'm very sad to see this. Takalani says 1.6 is D. Koki is saying it's B. JJ is saying it's C. Calvin is saying C. JJ Simbu is saying it's A. Hey, this is very sad. Sam Mix-a-Lot is saying it's A. Mbali is saying it's C. Hey, guys, what a one. Habo Kanya saying it's C. JJ is saying C. Okay. Neha is saying 40 degrees corresponding. JJ is saying corresponding angles. Yeah, I can't get that one. Say you guys. Kimatata fair. Life is full of problems. Let's solve this thing, guys. Please. Let's quickly just review for lines, guys. Okay, let's start here. When we have lines that are parallel, this is very important. The minute we say lines are parallel, guys, what are we saying? If this here, let's say they put 40 degrees here, this angle, if they put X there, what's happening here? Okay, Okay, let's go and relook at this sketch. Where is X? Okay, I think the placement is like this: AB parallel to CD. Okay, 40 degrees X. Okay, so I need to introduce you to fun, because some of you're not having fun whilst you're doing maths. Okay, the F formation, okay, has to do with corresp angles. Okay, and then we state the lines that are parallel. Corresponding angles, the lines that are parallel. If you have what we call a transversal line, then you have on top of this line an angle, on top of this line an angle. Top equals top. On top of this line, we are equal to on top of that line. We say these angles are corresponding. If the lines are parallel, we say that those corresponding angles are actually equal. So we always write corresp angles and we state the parallel line. So let's go here. This parallel line on top, this parallel line on top, on the same side of the transversal line. Top, we are equal. Also, guys, corresponding also has to do with bottom. We have an angle at the bottom. This angle is equal to the angle at the bottom of the other parallel line. So we also refer to these as corresponding. That's bottom is equal to bottom. Okay, so yes, Mulemo, 40 is actually 100% correct. Please, guys, F shape has to do with top, we are equal, bottom is equal to bottom. Top is equal to top, bottom is equal to bottom. But we are bottom of the parallel line equal to bottom of this parallel line, and it must be on the same side of this transversal line. Don't ever mix that up, please. Then we have co-interior. Okay, I call them the armpit angles. Where it stinks, you see where it stinks, go into your armpits. This is your first armpit, this is your second armpit. These are your lines, these are your arms, this is one arm. Okay, let's just write your fingers there, and then this is your second arm. There are your fingers. You are extending your arms like that. Those are your armpits where it stinks, the amakwapa. So these two angles, we say when it stinks here, what happens? We add roll on so that we can make it smell better. We add what? Roll on. We add something. So please, guys, we add the two angles. The sum is 180 degrees if the lines are parallel. So we call these the co-interior. The word co means together, and interior means inside the lines, inside. So these two angles, this angle and that angle, are not equal, but they add up to 180 degrees. Are we together, guys? The sum, we say the co-interior angles are supplementary. Then we look at N or Z. These are alternate angles. Okay, yes, makwapa plus makwapa equals 180. Makwapa plus makwapa, we must add roll on. We add the two angles together, sum of 180, co-interior angles. When we write the reason here, we say co-int angles, and then we always state the lines that are parallel. If it's AB, which is parallel to CD, we write that. AB is parallel to CD, please, very important. Then here we have Z or N. This Z can be this nice Z like this, or it can be a funny looking one Z, but it's those angles, guys. Okay, N or Z, these are the two angles. If the lines are parallel, we say that the two angles are equal. The Z effect, we call these alt angles, and then we always state the lines that are parallel. Okay, so I hope you understand this, guys. F corresponding angles. Okay, top and top are equal, bottom we are equal. Co-interior angles, the co-inside angles, where the armpits are, where your arms are, where your fingers are, your arms, your armpits, you add, roll on, you add the two angles, the sum should give you 180. So these angles are not equal. The sum gives you 180. Then these ones, they are equal. So alternate angles, they are equal. Corresponding angles, they are equal. But for co-interior angles, we say the sum is equal to 180 degrees. Okay, so come back to here. What did they say here? What is the value of x? So hopefully now we all understand that x, all right, should then be equal to what, guys? Okay, go back. I'm gonna go back to that option. Yes, thank you very much. It is 40, man. Okay, none of this funny stuff you are telling me here. There, the diagram. If AB, there we go, we are told if AB is parallel to CT, because remember, it is when the lines are parallel that we say that the corresponding angles, they are equal. So if AB is parallel to CD, then X is definitely equal to 40 degrees. So our option is C, guys. It is C. And if, let's say, we were actually answering a question where there was no multiple choice, we would write the answer and say X is equal to 40 degrees. And then when we write our reason, you must say, in short, corresponding angles. Then you state the lines that are parallel. AB is parallel to CD. AB is parallel to CT. Then it makes sense. Then we are happy if you are answering questions when you say X is 40 degrees, corresponding angles, AB is parallel to CT. It means you know exactly what you are doing and the reason is satisfying to the soul. Okay, please. Okay, all right, so I'm just going to now go to the next question. I think we are over that one. Let's go to the next one. 1.7. No, Lilita, there's no need of because they are equal. No, we don't have to write that one. The reason that is acceptable, that is in the acceptable reason document, is corresponding angles. All right, remember, you saying X is equal to 40. You are saying the angles are equal. All right, this here is enough. X is equal to, the two angles are equal. This is enough as your statement. Okay, and then after the end, you say corresponding angles. Why are you saying the two angles are equal? It's because they are corresponding angles based on the fact that the lines are parallel. AB is parallel to CD. We can then conclude and say X is 40. So this is fine. We don't say corresponding angles equal. We just say corresponding angles and we state the lines that are parallel. That's enough. That suffices. Okay, no need for equal. There, you have told me X is equal to 40. Thank you very much. What's the reason? That's what I want. I want the reason. Corresponding angles. And then you state the lines that are parallel. So for all these cases, F, U, and N, if you say this angle plus this angle is equal to 180, when you write your reason, you must say to me co-int angles. Then you must state the lines that are parallel, whatever those lines are. Okay? I hope you understand what I'm saying. You must write the lines that are parallel for you. What about N? The minute you say alt angles for your reason, you must state the lines that are parallel. That's all. You must state the lines that are parallel. That's your reason. You write alt angles and then you state the lines that are parallel. Co-interior angles, you state the lines that are parallel. Corresponding angles, you state the lines that are parallel. You state the lines that are parallel. You state the lines that are parallel. And let us forget this part, stating the lines that are parallel. Remember, these angles, the corresponding angles are equal. The co-interior angles, they are supplementary, and the alternate angles are equal due to the lines being parallel. So you must have this as well to substantiate as your reason for why you are saying what you are saying. Please. Okay, so I'm just going to X, guys, has nothing to do with parallel lines. Remember, the X1, okay, is just vertically opposite angles. You know, bagajuju. It's bagajuju stuff, mos. You know, like it for the pirates. This angle is equal to that angle. That angle is equal to that angle. All right, that's vertically opposite angles. So you just say vert op angles equal for your reason. Okay, because there are no parallel lines here. So I don't usually put the x, fun x, because the reason why fun is relevant is everything to do with parallel lines. Okay, so everything to do with parallel lines is fun, but for x, no man, you know, it's lines, but not parallel. So this angle is equal to that angle. That angle is, this one is equal to that one. Okay, all right. So that's vert op angles equal. Not a problem there. Okay, I like it for the pirates. I like it for the pirates. Okay, let's go back to the paper. Wait, guys, you guys are asking too many things there. I can see you. Let's see. Let's go this one now. We are here now. Next question. In the figure below, AB is equal to AC 1.7. AB is equal to AC. And AE is equal to AD. Why is triangle ABE congruent to triangle ACD? I repeat, in the figure below, AB is equal to AC. So what I'm going to do is I'm just going to redraw this diagram so that I can then utilize it to explain so that you guys have clarity. So we have A, D, B, and then we have A, E, C. All right. Now they are saying AB is equal to AC. AB is equal to AC. And then they are saying AE is equal to AD. AE is equal to AD. And then they are saying, why is triangle ABE congruent to triangle ACD? So ABE, we need to be able to identify, okay? And then triangle ACD, we need to also be able to identify. Okay, now I wish I had some colored markings. Let's just see if I can't get some here. Colored markers. I'll be with you now. So we have triangle, because it helps to have different colors here so that you can see what you are working with. I know you can't see, right? Because I'm trying to get triangle ACD. Okay. All right, let me just move this just a sec, because I want to write down what it says. AB is equal to AC and AE is equal to AD, and then they are asking why is triangle ABE congruent to triangle ACD. All right, okay, and then I'm going to just redraw this diagram one more time so that I can have the colored one and also the uncolored one. D, E, A, B, and C. Now the memorandum is already on the page. You can go onto my TikTok. You can leave the live and go to the TikTok and go check out the memorandum if you want to. Okay, guys, you're more than welcome to do that. Okay, this is not the department paper. I don't know why people, this is a past paper written in KZN. I don't know why people think, I think some of you think when you join my live session, you are going to get a paper. Someone is going to leak. No, there's no paper leaking here. Here, I'm just doing a past paper that was done in KZN. All right. So please stop with this conspiracy theories. It's not going to help anything. All right. So guys, we are told that AB, all right? Remember, this is AB, all right? So this side is equal, as it says, to AC. Okay, so this is this entire, from here to there and from here to there, we are equal. Furthermore, we are told that AE, okay, is equal to AD. AE, where's AE? AE, all right, is equal to AD. AD, all right? Then they are asking, why is ABE congruent to what? To triangle ACD. So here in this diagram above, what I did, right, is I actually used some markings to try and sort of like show you what do we mean by triangle. This is triangle ABE, this one, right, in orange. And then they want us to prove why is triangle ABE congruent to triangle what? ACD. And they've listed cases there of congruency, and they are asking you to basically state which case applies for these, all right? Now I want you to tell me something. If you look at the first two letters, okay, for these to be congruent, AB needs to be equal to AC. Can we see AB for this triangle? ABE and ACD. Is AB equal to AC? Yes, of course, that is given. All right, so we can say AB is equal to AC. First two letters, I'd say we are good. Okay, why is that? It is given, all right? And I'd say that's our first S that we have there. We are furthermore told that AE is equal to AD. Now this AE that they are talking about is the first and the last, first and the last. Okay, so AE is equal to AD. That is also given to us. All right, that's our second S. All right, that's our second S. Now, be very careful. In triangle ABE and triangle ACD, there seems to be a common angle that they share. Right? Do you see that? Yes, there's a common angle that is shared for both triangles. Guys, here is triangle ABC, and here's triangle ADC. They have a common angle, which is angle A. So I would say angle A is equal to angle A. Angle A of the one triangle is equal to the angle A of the other triangle. They are the same common angle. So we can say common angle. All right, and I'd say that is our A. So it seems like we can say that triangle ABE is congruent to triangle ACD. Why? SAS. It is sus, guys. It's suspicious. It's so sus. Won't you say it's sus? No, it's sus. It's so sus, guys. It's so sus. Like it's giving congruency. It's sus. It's SAS. It's sus. Guys, I know you guys see SSA, but remember, our cases of congruency are SSS or SAS or SAA, which can either be AAS sometimes, all right? And then lastly, for right angle hypotenuse side. Okay, right angle hypotenuse side. Okay, so this is the important thing. All right, yeah, and that angle, as my man has just beautifully said, who's Mr. H there? That Mr. H, I love you there, H. Who's that? The one who said, hey stalker, Mokay 51, included angle must be in the middle. If you take these two triangles, in actual fact, you are going to notice that this angle A is a middle angle in between the sides. All right, and that's what's beautiful about it. Okay, so this angle A is definitely a middle angle. That is the equal angle. So that's why we say it's sus. It's giving sus. Okay, very sus. So one more time, I'm going to repeat this. What did we first say? Remember, we were given in the diagram and the fact that AB is equal to AC. They furthermore told us that AE is equal to AD. And now they are asking us, why is triangle ABE congruent to triangle ACD? So what did we say? The first two letters are equal from the given statement. AB is equal to AC. Remember, AB is the one side of the triangle and AC is the other side of the triangle. The two sides are equal. Y given S. AE, we were told, is equal to AD. First last is equal to first last. AE equal to AD. It's also given. That's our second S. Then angle A is equal to angle A. It is like that for real, guys, because if you look at triangle ABE and you look at triangle ADC, this angle A is a common shared angle for the two triangles. It's common to both triangles. So that's why we say angle A is equal to angle A. Common angles. That's our A. So we say triangle ABE is congruent to triangle ACD, and our congruency case that we have proven is SAS, side, angle, side, because we have 4 cases of congruency, and through this development or argument for this case, okay, no. So the question that is being asked by Mokay51, is it a must to write the conditions, reasons while proving? No, it's not a must. You don't have to write this SSA. I personally do it because it helps me with my conclusion at the end. Okay, I usually tell my learners that I do this, all right, so that I can acknowledge, okay, this is a side, this is a side. This helps me keep stock of what I have actually used to develop my case, so that when I write my concluding statement, this reason is there. Because remember, in order for me to get the last and final mark, I need to have this case stated at the end for when I write my concluding statement. If I don't have that, then it's a problem. Okay, how did I know that angle A is an angle? Because it is. Guys, all right, let's go over a few things here. This is triangle ABE. Look, listen to me. Triangle ABE. This is angle A, this is angle B, this is angle E for triangle ABE. This is triangle ADC. This is angle A, this is angle D, this is angle C. You can see that for these two triangles that I was asked to prove their congruency for, we can see that this angle A is a common angle, which is why in my case you find me saying angle A is equal to angle A to strengthen the case of congruency for SAS, because I had two sides. I am missing one more thing. It could either be a side, it could be an angle, but it is fortunately an angle that I can actually prove that it is equal for the two respective triangles. it's angle A that I can prove is equal for this reason, because it's a common angle. So therefore it helps me then to develop my case as SAS being the case of congruency that I am proving. Okay, so please guys, I really appreciate Neha. Neha is you're making my heart very this guy is this guy or girl who, you know, you are making my heart live for joy. Guys, have respect. He's helping us. Thank you so much. I really appreciate that. Okay, I really appreciate that sentiment. It is heart touching. You don't have any idea. You guys don't understand the purpose, okay, of doing this. Okay, guys, I post these videos onto my YouTube channel. Unfortunately, I have to, in the interest of time, I have to move on, because I don't know how many times I've explained this problem. I feel like I'm going to be saying the same thing over and over again. All right, I think in the interest of time, I'm going to have to move on. Sorry. All right, let's move on to the next question. Let's move on. Okay, it seems like I need to go to the next page. Here we are. Two triangles are similar if. Let's see if people understand the concept of similarity. You see, through the problem I did 1.7, we were able to cover the concept of congruency. You now know, you saw me prove one case, but you know there's 3 other cases you could utilize to prove congruency if it works. Okay, let's look at 1.8. I'm glad you're doing the same paper. Okay, the two triangles are similar if 1, A, all angles are equal, B, corresponding angles are equal, C, corresponding sides are equal, D, right angle, hypotenuse side, and one other pair of equal sides. Let's see, what did the masses have to say? All angles are equal. B, corresponding angles are equal. C, corresponding sides are equal. D, right angle, hypotenuse, and one other pair of equal sides. What do the masses have to say? Two triangles are similar if what? Yeah, so I see you guys, you are saying varied things. Okay, A is definitely incorrect. It can't be all angles are equal, no ways. All right, A is wrong. Okay, all right, A is super wrong. If you say all angles are equal, then that's a problem. Okay, that's a problem. That is a problem. Okay, B, corresponding angles are equal. Now B is giving very nice vibes. All right, corresponding angles are equal. I agree with that one. Okay, C, corresponding sides are equal. That's query. That definitely does not qualify at all. And then lastly, right angle, hypotenuse, and one other pair of equal sides. No. Remember, right angle, hypotenuse side has to do with congruency. So D is a case for congruency. C, corresponding sides are equal. That is a case of congruency, side. B, corresponding angles are equal. Yes, definitely. Corresponding angles are equal. The answer has to be B. It can't be A, it can't be C, it can't be D. Okay? Corresponding angles are equal. And I want to just explain, guys, why that is the case. All right, guys, similarity. What is similarity? Similarity, guys, is simply this. Okay, corresponding angles equal. What do we mean by that? Guys, we mean this. These two triangles, I'm sure you can see, one is small, the other one is big. If this is A, B, and C, and this is D, E, F, all right? For corresponding angles equal, in other words, this guy says hello to the same guy in the same position. Angle A and angle D, we call these in the same position angles that are equal. We call these corresponding. You guys need to go and look up the word corresponding. What does the word corresponding actually mean? I know in parallel lines we talk about corresponding. The fact that this angle, guys, it has to do with this thing of the same position in the same place. The word corresponding means same position in the same place, you know, because if you look at this line that's parallel, the position of the angle is at the top. This line that is parallel, the position of the angle is also where? At the top. So these we say are corresponding angles for parallel lines. This here, guys, these two angles, same position, just for different triangles, but these are also angles in the same position for two triangles. Okay, so this angle we say is equal to that one. Angle A is equal to angle D. So these are angles that are corresponding. This angle is equal to that one. You see, same position, same place, angles are equal. Angle B is equal to angle E. C, angle C is equal to angle F. All right. Now, the first pair of angles equal, the second pair of angles equal, the third pair of angles equal. So we can say triangle ABC is similar. Look at the symbol that we use. Congruency, 3 horizontal lines, that's congruency. Similarity, 3 vertical lines. Triangle ABC is similar to triangle DEF. What's the case? A, or angle, angle, angle. So that's why we say corresponding angles equal. All right. Now the question is, what about the sides? What do we say about the sides for two triangles that are similar? Okay, we say that the sides are in the same proportion. The sides are in the same proportion, or we say ratio. Ratio means fraction. The sides are not equal, guys, but the sides are in the same proportion. The word proportion speaks to ratio. The word ratio refers to a fraction. Hololo. Helele, halala, halalu, helala, halalu, helele, halalele. So what does that mean, guys? It just simply means if the triangles, okay, that's why I'm going to write this down. Similar, okay, means equiangular. All right. Equiangular or similar speaks about sides being in the same proportion. Okay, so similar. Thank you so much for that, Rose. So beautiful. Thank you so much. So kind. Similar means equal angles. Okay, but at the same time, equal angles also means sides are in the same proportion. If the sides they are in the same proportion, then we say that the triangles are similar. Triangles are similar, they're in the same proportion. They're in the same proportion, they are similar. If they are similar, they have equal angles. If they have equal angles, they are similar. Okay, so similarity can be proven in one of two ways. You can either prove that the corresponding angles are equal, okay, or you can prove that, listen guys, you see AB, we say AB over, hey, look at this, AB over DE, all right, BC over EF, AC over DF. Right? You usually find a situation like this, and we're just going to do this 2, 3, 4, 6, 9, 12. Look at this, guys. So remember, I said to you, you can prove similarity if the angle A is equal to D, angle B is equal to E, angle C is equal to F, then basically you can conclude triangle ABC is similar to triangle DF, angle. But also AB, okay, AB over DE. Where's AB? Here is AB. Where is DE? Here is DE. What's AB? AB is 2. What is DE? DE is 6. What is BC? BC is 3. What is EF? EF is 9. What is AC? AC is 4. What is DF? DF is 12. I'm going to repeat this again. What's AB? AB is 2. What is DE? DE is 6. What's AB over DE? This is a fraction that I am. AB over DE, 2 over 6. BC over EF. EF. What's BC? 3. What's EF? 9. This side is a corresponding side to this one. Same position for different triangles. Same position, 2 over 6. Same ratio. The sides are in the same proportion. What's proportion? Ratio. What is a ratio? Fraction. You did ratios in term 1, grade 9, and you learned that a ratio is the comparison between two quantities of the same type. Okay, so for similar triangles, we don't say the sides are equal, we say the sides are in the same proportion. The corresponding sides are in the same proportion, ratio, or fraction. This word ratio and fraction are meaning the same thing. Proportion is explained in ratio and fraction. So if I then write my sides in ratio form, I don't say AB is equal to DE. No, I say AB over DE. What is it giving me? 2 over 6. BC over EF. BC over EF, 3 over 9. That's another fraction. First and last. First and last. What's first and last? AC. AC. DF. First and last. DF. What's AC? 4. What's DF? 12. What's 2 over 6? 2 over 6 is 1 over 3. What's, if I simplify, what's 3 over 9? 1 over 3. What's 4 over 12? 1 over 3. What have we just discovered? we have discovered that our corresponding sides are in the same proportion, ratio, fraction. Here it is. AB first 2 over DE gives me 1 over 3. Last 2, BC over EF gives me 1 over 3. First and last, AC over DF also gives me 1 over 3. What am I seeing? The sides, the corresponding sides are truly in the same proportion. What then can I conclude? Therefore, triangle ABC is similar to triangle DEF. What's the reason? Corresponding sides in proportion. It is just 3. AB over DE is 1 over 3. You could write the ratio in reverse. You could say DE over AB. You will get 3 over 1. EF over BC. You'll get another 3 over 1. DF over AC. You will still get another 3 over 1. If you do it that way, it is still correct. Okay? It's still correct. Okay? So guys, what was Sir trying to explain here? Okay? Thank you so much, Chanel. You are 100% correct. Many people are focusing on the comments. And the reason why they are lost or they are not getting it is because they are not really focusing on what I'm saying. Rather, they are focusing on what is being written in multitudes in the comments. Should I rather than switch off the comments and then have people listen to me exclusively? Okay? Because, I mean, I'd hate for that boredom to fall upon you, you know. But that's the thing. Okay? Okay, so is it the same if I write ratio instead of proportion? Yes, it is the same, guys. That's why I've said here. Okay, I'm going to just repeat this again. Similarity means 1, corresponding angles are equal. What do we mean? The corresponding angles of that particular the two triangles should be equal. In other words, angle A and angle D, which are in the same position for the two respective triangles, are equal. Angle B is equal to angle E, which is also in the same position. Angle C and angle F, corresponding angles in the same position, they are equal. Then when we conclude, we say triangle ABC. Guys, look at even the order. This angle A, angle D, they should be equal. Angle B, the second, should be equal to angle E, equal. Angle C should be equal to angle F. It serves the point that this angle should be equal to that one. Corresponding, same position, angles equal. Same position, angles equal. Same position, angles equal. All we need is the reason. All right? If it's given, then it's given. Okay? But all we need is the reason to substantiate why we are saying the two angles are equal. In this situation, we may well say given. Okay? Okay? So I am saying that, guys, similarity can be proved using the corresponding angles that are equal. The minute the corresponding angles are equal, in other words, they are equiangular, we say that the triangles are similar. That is why when I say angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F, for reasons given to me, I can then conclude that the two triangles in the order are similar. What is the case? Angle, angle, angle. 3 of the best angles that are corresponding are equal. Are you with me? That's one way of proving similarity. Corresponding angles are equal for the two triangles. 2, the second way to prove similarity is to prove that the corresponding sides, they are what, guys? They are not equal, but they are what? They are in the same proportion. Oh What does that mean? I can take Mr. If they are saying prove that triangle ABC is similar to triangle ADF, triangle DF, then it's a matter of checking. Let us check first this ratio and write it alone. AB over DE. Someone else might think in reverse and say, no, let's start this side. DE over AB. Okay, guys, it doesn't matter, man. It doesn't matter. Okay, but what matters is that if you start this side, then you must continue for the next ratio to start where? This side. And for the next ratio, you must start this side. If you start on the other side, then you must continue to start on the other side here and start on the other side there and start on the other side there. Are you with me? So if we say AB, it means we are starting with this triangle. Then we must continue starting from this triangle. AB over DE. Then we write the ratio. 2 over 6. Remember, AB is here. DE is there. 2 over 6. There it is, 2 over 6. Okay. Yes, super not angel. You lose a mark if you don't conclude. So for instance, for angles, you must write the reason. Write the angles that are equal, write the reason. Write the angles that are equal, write the reason. Then conclude. Then state and write the case. If you don't write the reason, boom, marks are gone. You know, and if you are a learner like some of my learners and you are always aiming for 100% and you butcher it with this thing, then hey, geometry, no reasons, hey, yeah, you are saying goodbye to marks. Last one, corresponding sides are in the same proportion, ratio, fraction. Please guys, AB, like I said, over DE. You start this side, you end this side, first fraction. You start this side again, BC over EF. There it is. You start this side again, first and last, AC there, over DF there, 4 over 12. You get all your fractions simplified. You see, ratio same, ratio same, ratio same. Therefore, we conclude triangle ABC is similar to triangle DF. Reason, corresponding sides in proportion. On corresponding sides, can we use eyebrow, smile method? Definitely. I love that. Mama boy, it is like saying on corresponding, can we use eyebrow, smile? I love that. That's beautiful. Is this more of like what you're thinking about? There's the first eyebrow, then this is the second eyebrow, and then they smile. I like that. That's beautiful. Okay, did you hear that? Look at this. Mama boy is helping us a lot there with some ways to remember. You know, think of your eyebrows. AB over DE. That's your first eyebrow. AB over DE. Second eyebrow, BC over EF. There's your second eyebrow. Then your smile. I mean, what is it? What are two beautiful eyebrows without a smile? AC over DF. AC over DF. And then you simplify, guys. Make sure you simplify your fractions. You see, oh, they are the same, the fractions, which means really and truly they are in the same what? Proportion. They are in the same proportion. We have the same ratios. We have the same fraction. That's why we say corresponding sides must be in the same proportion. If they are, then we say the triangles are similar. Triangle ABC is similar to triangle DEF. Corresponding sides in proportion. Okay, guys, I think I've made it clear with the similarity, at least the basics. Remember that this is all coming from what? It's coming from the fact that we are doing multiple choice questions, and in the multiple choice questions, what are we discovering? There is content that if we don't understand, it becomes difficult to answer the questions. Okay? No. This is not the long method. This is a method that you must use in order to prove that the triangles are similar. If you are using corresponding sides, you must state the respective ratio. Eyebrow eyebrow, and then our smile. Then we see, oh, 1 over 3, 1 over 3, 1 pair, 1 over 3 with my first corresponding, my first ratio, second ratio, third ratio. Then I can conclude triangle ABC is similar to triangle DEF, corresponding sides in proportion. Okay, guys, I'm done. I think I've over-explained it. Please, yes, you lose marks. You lose marks, guys. Those who know I've been explaining this. Those who are saying explain congruence, guys, I did a congruency question. Okay, like I said, there are people who are here. I can't halt this thing for the purpose of entertaining the select few that basically are maybe coming in now. Okay, I explained many times, guys. Those who are here, they know. I feel like now I'm just going to be a broken record, stuck answering the same thing. 1.9, the property, okay, the property of a kite is A, all sides are equal, B, 2 pairs of adjacent sides are equal, C, adjacent sides are perpendicular, D, diagonals bisect each other. Now, all those who know their properties very well, I tell my learners all the time, guys, if you don't have a poster that you have designed, I see you many times in classes for GEC and for other projects doing nice posters as groups, and I wonder to myself, why don't these learners design beautiful posters for properties that are important, which they know they'll be using not only in grade 9 but even in the future? Your quadrilateral properties, guys, are so important. You are going to see those who want to do pure maths in grade 10 next year. You are going to need those properties to be there on the wall. Take down Beyonce, take down Umahu, take down all these beautiful artists of yours. Take them down and put up the properties. Okay, put up the properties so that you can have them to use. If you are going to do maths in grade 10 next year. Maths is so beautiful when you know these things and know them well and they are memorized. So B is the answer, right? You guys are 100% spot on. 2 pairs of adjacent sides are equal. Very good. It can't be any other option. A kite does not have all sides equal. C, adjacent sides are not perpendicular for a kite. Please, guys. And then lastly, D, diagonals of a kite don't bisect each other. It's the long diagonal that bisects the short one. That's it. But they don't bisect each other. The long one bisects the short, but the short one cannot bisect the long one. So that's why we don't say they bisect each. They don't bisect each other. So it has to be B. 2 pairs of adjacent sides are equal. 1.10. The property of a trapezium is A, all sides are equal. What rubbish? That is rubbish. B, diagonals bisect each other. Aibo. People, don't make me laugh here. C, 1 pair of opposite sides are parallel. 1 pair of opposite sides are parallel. D, both pairs of opposite angles are equal. Both pairs of opposite angles are equal. Right? So which one is it? Okay, I can see the large majority is saying C. Very good. I love it. You guys are 100% spot on. Guys, those were the multiple choice questions. And did you see how much content or concepts we were there unpacking just for multiple choice? Hey, and you say, Matsy, hey guys, and multiple choice questions. And GEC, some of you end of there writing GEC, there's a lot of multiple choice questions there. And those multiple choice questions, some of them, they require you to do working out on the side before you can choose the right option. All right, so let's be spot on. And you could see some of the questions that were in the multiple choice required us to do some writing down, rough work on the side before we choose a relevant option. Let's not play guessing games with multiple choice, guys. And please, let's stop skipping a multiple choice question. Some of you say you don't know what the answer is and you skip the multiple choice question. Are you crazy? You must choose at least a relevant option. At least if you feel like you are out of the woods with understanding, eliminate the options that you feel like don't apply until you are able to sift out the most accurate option. Please, guys, we must become well versed in doing multiple choice questions and choose. Please, guys, don't do this thing of skipping. Okay? Mama Poet is asking, are these questions similar? Guys, I don't know. I have no idea because, like I said, I don't know the paper. I don't know anything. Okay, let's move on. Question 2, given the graph below. Now we are there, because there were people who were saying do graphs. Determine the x-intercept. Determine the x-intercept from the graph. All right, the graph is there. The graph is there, guys, and they are saying determine the x-intercept. They are saying we must determine the x-intercept. All right, so let us just zoom in a little bit more there. I know we may not be able to still see it very well, but if you look at that thing there, there's one. If you look at the x-axis, you have 1, 2, 3. They are saying determine the x-intercept. Guys, remember there's a difference between them saying determine the x-intercept and them saying determine the coordinates of the x-intercept. There's a difference. If they had said coordinates of the x-intercept, then we know our answer, how we write it. But if they say determine the x-intercept, then there's also a way of writing the answer. And I like what people are saying in the vast majority in the comment section. All right, and I just want to say this, and I want to reveal this so that I love it when people we are in the same page and we are all drinking from the same water of life, and there's no confusions whatsoever. Okay, so let me zoom out a little bit here. So if they had said determine the coordinates of the x-intercept, then simply put, we know that point is on the x-axis, and we know that on the x-axis, if it's the x-intercept, y is 0, the x value would be 3. That's if they had said they want the coordinates. We would write the coordinates. The x-coordinate is 3, the y-coordinate is 0. But since they want the x-intercept, we just write x is equal to what? 3. That's it. X is equal to 3. Done, finished. That would be your answer for 1 mark. Are we together, people? Two different things. If they say determine the coordinates of the x-intercept, we write 3 and 0. Remember, the x-intercept is where y is 0. So our y value must be there. It is 0. But the visible x value at that specific point is 3. So it's 3 and 0 if they want the coordinates. Okay, remember, coordinate is what we refer to as an ordered pair. An ordered pair is when we write our x value and our y value in brackets together. That's our ordered pair or our coordinates. But if they want just the x-intercept, then we can say x is equal to 0, or some people say x-int is equal to 3, just to emphasize that this is my x-intercept, it is equal to 3. Okay, I hope we understand this thing together. Thank you so much. If you understand it, I love it for you. You then means you are learning something, and me and you, we are going to be happy. Okay, let's move on to the next question. The next question says determine the y-intercept. So once again, when we zoom in there, we are counting there at the bottom of y. -1, -2, -3, -4, -5, -6. Be very careful, guys. -6. Okay, -6. Once again, if they wanted the coordinates, let's be very careful and read the question. If they wanted the coordinates of the y-intercept, what would we write down had they wanted the coordinates of the y-intercept? Because I see you guys writing the y-intercept. You guys are 100%. Y is 6 or y is equal to 6. That's 100%. But had they said they want the coordinates, what would have been our answer? Remember, this is the y-intercept. So if they wanted the coordinates of the y-intercept, what would we have written? We would have definitely, remember the y-intercept, it's where we let x be equal to 0. Mbali, you are 100% correct. I'm hoping you guys can see what Mbali has said there, what Mbali has written. We must write the answer that way. You write the brackets, you write the 0. Please guys, the brackets must be there. If there are no brackets, then you are doing something that shouldn't be done. The brackets must be there. Okay, so let me just approve all these other comments, but also let's just take note, the brackets must be there. Okay, thank you very much. Let's move on to the next question. You guys are hey, you guys, and you can see when they say y-intercept, that's where the straight line is overlapping. If they're saying the y-intercept, the function, the straight line is overlapping the y-axis. If they say the x-intercept, the straight line is overlapping the x-axis. Okay. I'm sorry, Malimo, if your comments can't be posted. Maybe it's just restrictive boundaries, but I receive it in good spirits that you are saying the right thing. Let's go now. I'm sorry guys if your comments is not being posted. I'm very, very sorry about that. Let's go on to the next question. Determine the gradient of the graph below. Guys, I just want, if you can't see in the diagram, okay, hopefully you guys are counting. That's -1, -2, -3. So our x-intercept is -3. I hope you can see that. Okay. So our x-intercept, where the graph cuts the x-axis, it's cutting it at -3. And then our y-intercept, the graph is cutting the y-axis where? At -3 as well. What do they want now from us? Or is it 6? Okay, I'm not saying that very. Oh, it's counted in twos there. -2, -4, -6. So thank you so much, Neha. All right, I was not seeing that very well. Thank you so much, Neha. Neha, you just got you brought clarity there. I just want to see, is it the same with the no. So the x-axis there is -3. So it's -1, -2, -3. So on the x-axis it's definitely -3, but on the y-axis the graph is cutting at -6. Okay. What do they want us from us now? They want us to determine the gradient of the graph below. So how do we calculate the gradient, guys? How do we calculate the gradient? Okay, so hopefully we can see that -6, and there it's at -3. We want the gradient, and remember our formula for gradient, m is equal to y2 minus y1 over x2 minus x1. So it's nice, Kengoku, guys, I'm sure, to see that if we can get the coordinates of those intercepts, then we can use the formula nicely, no problem. You see? So it's nice to know how to write down the coordinates. So here for -3, the x-intercept, what would be our coordinates there? Okay, yes, identify the points. So we can see there we have -3 and who? And 0. X is -3. On the x-intercept, we know y is 0. So that would be -3 and 0. Here, what would be the coordinates? Okay, I think let people tell me what would be the coordinates there. I often find that my learners, and I was seeing even in tests at my school, when we were doing short tests, learners were having a hard time writing down the coordinates of points. You know, it's like there's this common error learners tend to make. Let's just remember, guys, that when we are on the x-axis, the y value on the x-axis is always 0. When we are on the y-axis, the x value here is always 0. You see? So Mbali, thank you so much. Mbali is 100% spot on. 0 and -6. So those are our coordinates for the 2 points that we have there. Okay? Yeah, because that is negative 6. Remember, we are on the negative part of the y-axis, whereas this side we are on the negative part of the x-axis. This is the positive part of the y-axis, and this is the positive part of the x-axis. Also, guys, something else to remember, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. Quadrant 1, quadrant 2, quadrant 3, and then quadrant 4. What was the question asking again? Simply put, we are being asked to determine the gradient of the graph below. They only want the gradient, guys. Okay, just the gradient. Just the gradient. So what I did is I actually then was able to show you the exact points, all right, so that we can be able to use exact points to calculate the gradient. Okay, that's why I basically drew this graph for you. Okay, yeah, I drew this so that you guys can see that, okay, that's negative 3, so therefore my coordinate at that point is negative 3 and 0. Then here, that's negative 6, so that you can know that my exact coordinates are 0 and negative 6. Please take note that sometimes in these graphs, straight lines, sometimes in these graphs, what ends up usually happening is that sometimes your y-intercepts and x-intercepts are not clear, and usually the graph or the straight line will pass through places where you can identify the points. For instance, I can see that there are other coordinates I could identify in this graph. Okay, can you see the other points that you can identify? For instance, can't you guys see negative 2 and negative 2, for instance? Negative 2 and negative 2, where x is negative 2 and y is negative 2. I can see that the graph also passes through that point. I can also see negative 1 and negative 4 are also points on the graph. I know, guys, it's a bit blurry, and that is because the diagram itself, like when I took the screenshot, it wasn't as pashash or clear. Okay, but I tried to zoom in a little bit. So for instance, there at the top it's negative 1, negative 2 to negative 3. Okay, yeah, and then as it goes down there, it's negative 2. It counts in 2s. For the y-axis, it counts in 2s. For the x-axis, it counts in 1s. Okay, so I'm sorry about that. I'm sorry that you can't see that. So if we calculate the gradient, anyways, let's just go and calculate the gradient. So I say this is my first point, so that's x1, y1. Then I say this is my second point, so that means that's x2, y2. Then all I do is I come and I substitute here. Remember, y2 I said is negative 6. The formula has minus, so I write minus. What's y1? y1 is 0, so I write 0 over x2. What's x2? x2 is 0. The minus sign in the formula I write down. And then what follows? Negative 3. x1 is negative 3. So remember, in brackets, I'm going to write negative 3 because there's already another negative, which is very important. Then I sort out or resolve the sign. Minus 6 minus 0 over 0. What's a negative times a negative? Remember, brackets are there. So what's a negative times a negative? That gives me a positive 3. Okay, and then last but not least, what's negative 6 minus 0? That gives me negative 6. 0 plus 3 gives me 3. And then when I divide, guys, nicely, negative divided by positive is negative. What's 6 divided by 3? That gives me 2, and negative 2. Okay, so it is not a negative half. It's not 1 over 2. It is negative 2. And guys, remember, does this gradient answer make sense when you look at the line that is drawn? Remember, what did we say earlier on? There were some notes that I wrote down, and I said if m is greater than 0, it's positive. Increasing line. If m is less than 0, meaning the gradient is negative, decreasing line. The gradient is -2. Do I have a decreasing line? It makes sense. Yes, I do. So the sense behind the graph and its straight line, the coordinates that I wrote down, and ultimately my answer for the gradient. It makes sense. This is not just an answer I'm going to get and just move on. No, I'm going to get the answer, go back to my sketch and verify if this answer makes sense in light of the straight line. The plane is crashing. Neha, I like that. Explosion there at the bottom. It's like, it's insane. It's like one of those explosions, you know, like you don't want to be on that plane as it crashes and as it goes down. Like you don't want to be there because it's like you don't want to be there, or forever falling, eh? Or you know how in your dreams sometimes you are being chased by someone and they're chasing you with like this big thing, and then you run to the edge of a cliff, and then you start falling, and you fall endlessly, and you never stop falling, and you are just like and you're like, what's gonna happen here? And you never hit the ground, you know, and you wake up just at that moment. So it's like crazy. And yeah. So I hope that makes sense. Anyways, gradient is -2. I'll pray for you. I'm praying for you right now. I'll definitely pray for you guys if you want. That's definitely for sure. Okay, so gradient is -2. Okay, I think that's calculated. We're done. Let's just go back. Let's go back. Okay, 2.3. Study the table and complete below and complete it to find the values of y. So hopefully we can all see that in the table, in the row that is above, we have x. We then have all the values of x listed: -2, -1, 0, 1, and 2. Then in the second row, we have y is equal to 3x plus 8, which is the equation, the rule, or the formula that we are using to basically get what? The output values, which is the y values. Okay, so like I said again, at the top, the first row, you have x, you have your values for x, -2, -1, 0, 1, and 2. Then you have a second row, y is equal to 3x plus 8, and there are missing values that you need to find, which you need to then calculate. Okay, so study the table below and complete it to find the values of y. So what do? We simply take all those x values one by one and we substitute them where? We substitute them in the rule, and then we get what? We get the values of y, and then that's that. Okay, so if you substitute -2 there, guys, okay, if you substitute -2 in that equation, seems like it's easy enough. All right, this is like what you did. I think it was in term what was it? What term was it? There's that term that you guys did, substitution. Okay, so that term was supposed to prepare you for term 3. Okay, so I'm sure you guys could easily get all of those answers very nicely without really breaking a sweat. I know you guys. I know. So I see Katlejo there. Yeah, this is very easy in the calculator. Very, very easy. I'm sure some of you even have that option in your calculator to use your table. All right, and you can just substitute these values nicely. But very easy in the calculator, definitely. Yeah, the table mode, Neha. Look at you. Neha is like Neha-ing it, eh? Okay, so the first one, -6 plus 8, that gives us +2, definitely. So we have 2 underneath -2. We substitute -1. We have 3 times -1. That gives us -3 plus 8, which gives us 5. So that person who said 2, 5, they are on point. We substitute 0, we get 8, because 3 times 0 gives us 0 plus 8 gives us 8. We substitute 1, that's 3 times 1. 3 times 1 is 3, plus 8 is 11. Then we substitute 2, that's 3 times 2, which is 6, and 6 plus 8 gives us 14. Okay. So I hope you guys understand it. Look at it. Morales is saying, if this is grade 9 maths, why am I doing it in grade 7? Okay, that is because grade 8, grade 9, grade 7, we're pretty much doing the same thing every single year. I don't know why you guys but obviously with a little bit of progress and add-ons as the years go by, so hopefully you don't chill too much when you get to the next grade. Okay, all right, let's go on to the next question. I think that one was pretty straightforward, guys. Very straightforward, no problem. Yeah, no, it's not the start of hell. Some of you guys changed, and the hell started with you inside. You are the ones that changed. The ones studious, focused learners, they changed to something else that I don't know. Okay, let's go. 3.2. Is it 3.2? What is happening here? How can we be in 3.2? Oh, okay, because I was like, what the freaking doodle? 2.3. Okay, here we are. 2.3.2. Plot the graph of y is equal to 3x plus 8 in the Cartesian plane below. So guys, obviously we are going to be reproducing a Cartesian plane from scratch, but remember, if you guys are provided with a sketch diagram in the test, then it means you use that sketch diagram to basically sketch your function. And what is beautiful here, if they say plot the graph of y is equal to 3x plus 8 in the Cartesian plane, what can we then do, really and truly? We can just use the y-intercept method. It makes life very easy. It's very straightforward. We don't have to really waste that much time. We can use the y-intercept method. Okay, just y-intercept method. What do we mean by y-intercept method? It means we just simply substitute. But remember, this one, where is this one coming from? This question, if we look at the previous one, y is equal to 3x plus 8. We are just going to use those points that came from the table. So I'm going to remind us, what were the points in the table? Okay, do you remember when we substituted -2, -1, 0, 1, and 2? What did we get? When we substituted -2, we got what, guys? What did we get? We got 2, right? No, wait. I'm going back to basically what we had done, because this question is a follow-up. 2.3.1. The follow-up question is 2.3.2. Okay, so we got 2 when we substituted -2. Okay, I think someone has helped us out there. 2, 5, 8, 11, 14. Okay, so I'm just gonna make sure that those are there. 2, 5. Okay, now what's beautiful is that this sketch paper that they will have for you, it's very well provided. Like, there's, things are already provided nicely there. Okay, so what we do is we simply use this graph paper to sketch our function, and it makes life easy. All right, makes life very easy. Okay, what I am seeing from this sketch graph, for instance, is we have 1, 2, 3 above the x-axis. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's 13. If we count in ones up until the top, it's up until 13. And you can see that your highest y value that you got when you were calculating is 14. So it's going to make life very difficult if we can't fit in all the values there. So what you can then do is you can probably use your y-axis and count in 2s. I would probably do it like that. Okay, 2, 4, 6, 8, 10, 12, 14. And then I would end somewhere way before. All right. Or alternatively, because I don't know why they provided a sketch paper that is not, they were supposed to provide a sketch paper that is, sufficient. All right. I hope you understand what I mean. But I just want to show you something. Okay, just quickly. Sorry. So I've just obviously this is not that graph paper, but I hope you get my point. Look at this, guys. When x is -2, understand this -2 and 2 are a point. It's -2 and 2. This is a point, another ordered pair, -1 and 5. This is another ordered pair, 0 and 8. This is another ordered pair, 1 and 11. And then lastly, this is another ordered pair, 2 and 14. So I have 1, 2, 3, 4, 5 coordinates, which I can then use and plot on this particular Cartesian plane. All right, so I'm not going to sketch the entire thing, but I just want to show you how you identify the points on your Cartesian plane. I think I did a video on my TikTok page where I actually showed learners how to identify your points. So your x values, they start from -2 all the way to 2. So I mean, that's nice, because all I can then do here is just say 1, 2, 3, all right? And then here I can just say -1, -2, -3 with my 0 there. Okay. All right. I hope you understand that. Then let's just say then here 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's just say 11, 14. What I want to do here is, okay, obviously, like you can see, guys, it's just that there's not enough space right here. But what we want to do is make sure that we are able to get to have this point inserted. Okay, so if we go here, where's -2 and 2? Where x is -2, but simultaneously y is 2. So I usually call this how your mother met your father. Yes, definitely, Neha. Your highest number, 14. Y should be 14. Your highest number should definitely be there. So here, I should have 14 inside. That's why I'm saying here, if you look at this graph paper, this one, look at this. If you count from the x-axis where it is, that's where 0 is, right? So if you go up, you count, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It ends at 13, which makes it so difficult to be able to sketch all the points that were in that table. Because what you want to do is you want to plot. Yes, the graph is not make sure. That's what I'm saying. The graph paper itself is not make sure. So what they need to do is make sure that they provide you with a graph paper that is sufficient. Okay? So anyways, let's just hope that if they ask you to sketch and they've provided you graph paper, that they provide you with a graph paper that is illegible, that is actually appropriate for the situation. So let's come back here. X, where's x -2? X is -2 here. Guys, understand this. X is -2 everywhere on this vertical line. When I say x is -2, x is not just -2 here. No, x is -2 everywhere on this vertical line. How your father met your mother. All right, so -2, let's just say, was your mother. That glorified, wonderful day, your mother decided to leave the house. And when your mother decided to leave the house, as young as she was, with that golden black hair that she possessed, whether it was golden, blonde, call it what you want, she decided to leave the house. And you know what? Your dad decided to leave his house as well. Why? Okay, y is 2 is here. But remember, when dad decided to leave, y is 2 is everywhere on this horizontal line. When he decided to leave, hey, things happened. Mommy and daddy met. They met there. So this is the point, guys. -2 and 2. That's where the point is. Okay. So I've just showed you how to locate your point. X is -2 is everywhere on this vertical line. Y is +2 is everywhere on this horizontal line. Where do they meet? Here. Okay, yes, they met in Japan watching anime. Very true. Let's look at this one. Where x is -1. Where is x is -1? Remember, x is -1 is there. It's everywhere on this vertical line. Y is +5. Y is +5 there. Okay. Okay, y is +5 there. Where do they meet, mommy and daddy? You're there. You see? They meet there. Okay. X is 0. X is 0 is everywhere on the y-axis. Y is 8. It's exactly there. Okay. they met there. This is actually the what? The y-intercept. Okay, so that's there. Let's move on to the next point. X is 1, y is 11. Where's x is 1? It's here. That's everywhere on this vertical line. X is 1 is everywhere on this vertical line. And remember, y is 11. Y is 11 there. Are you with me, guys? Y is 11 there. Here? Yeah, everywhere on this horizontal line. So they meet there. Then lastly, x is 2. Okay, or the 0 and 8. Okay, so aura, the 0 and 8. Please listen to me now. Remember, when you are here with the 0 and 8, this is 0 for who? This is 0 for x. Okay, this is 0 for who? For x. And this is y for who? For 8. So when you let what? X become who? Become 0. We call that the y-intercept. This is called the y-intercept. So it's on the y-axis where the graph cuts the y-axis. That's where x is 0. It's on the y-axis, everywhere on the y-axis. Then 8, y that is 8 is here. All right, y that is 8 is there. So we're meeting there. All right, it's almost as if like the mommy, all right, could leave the house, but daddy decided to visit, at the house. Yeah, decided to meet at the house and not leave. So mommy could have been anywhere, all right, 0 that is, could have been anywhere, up and down, up and down, up and down, but then mommy decided to go to daddy and meet. So that's there, 0 and 8. Because remember, guys, when we let x be equal to 0, y is 8. Letting x be equal to 0 means the what? It means the y-intercept. Where is the y-intercept? It's where the graph cuts the y-axis. Okay, yeah. So it's very important. Okay, that is the place of meeting. We are meeting where daddy is stationed. Yeah. So it's like mommy could have gone anywhere, but you know what? It's like it's like I saw you, like daddy stepped out of the porch, saw mommy there and was like, hey, you come over here. And then that's, that's, yeah. It was there at the porch, man. It was there at the porch. It was there at the porch, 0 and 8. Okay, then 1 and 11. X is equal to 1 everywhere on this vertical line. Okay, everywhere on the vertical line. Then y that is 11 everywhere on this horizontal line. Where do they meet? They meet there. Then lastly, x is 2 everywhere on this vertical line. And then y that is 14. Guys, y that is 14, you see, remember I said I didn't have space, so let's say it's there somewhere, so we know we are meeting there somewhere. Guys, what you should notice is that I'm going to take my ruler and I'm going to connect these points, all of them. This, that, this, and that. That is going to produce a straight line. Okay, let me just grab a pencil. You take a ruler, guys. You use a ruler. You take a ruler, you connect, and then you label y is equal to 3x plus 8. If you look at the coefficient of x, the gradient is positive. Look at the direction of the straight line. This diagram makes sense if you look at the gradient, because we did say m is equal to 3. That means the gradient is positive. Use a ruler, guys. No, I can't personally use a ruler, because what I'm doing is I'm holding, okay, I'm holding my phone with the one hand. I can't use a ruler, but you guys will use a ruler and you will connect the dots with the ruler, because they will basically form that beautiful uninterrupted straight line for you. Okay, please, that's what we call using the table method point by point by point. We call this a continuous line. It's continuous. It's not discrete. It is continuous. Continuous. Okay? Yeah. Any questions? Any questions at all? I hope that's clear. Nice straight line there. It's a linear. Yes, a linear function. Linear. Straight line. Okay. Look at 2.4. 2.4 simply says draw the linear graph for y is equal to half x plus 2. This one, guys, very easy. All we do here is we use the dual intercept method. That's it. Just use dual intercept. Don't waste time. Dual intercept. Okay. Yeah, dual intercept. Kanya, aren't we supposed to put those arrows? Remember here, it starts at -2. It ends at what? At 2. So yeah, we are just going to have that graph limited to those points. Yeah, well, if you don't put the arrows for this one, you will not be particularly penalized because it starts at -2, it ends at 2. Okay, yeah, so I think that would be fine to basically have those end points because it starts at -2, it ends at 2 according to the table. Okay, where we can actually go ahead and make sure that we write the arrows at the end would be with this one. Here we are told to just draw the straight line. Y is equal to half x plus 2. There's no table provided, so we are just going to simply use, guys, the dual intercept method. We are not going to waste time. Okay, yes, super not angel, it is just a limited graph because we are given a starting point for x and an end point for x, and in between points -1, 0, 1 and 2. So that's why we can just simply use just the points, and then we start and end at those points, and that's it. This one, dual intercept method, y is equal to half x plus 2. Guys, let's just use the dual intercept method. Here we just find the x-intercept by letting y be 0. Remember, when we want the x-intercept, we let y be 0. And then we find the y-intercept by letting x be 0. Okay, makes sense? X-intercept, let y be 0. Y-intercept, let x be 0. X-intercept, let y be 0. We can just say 0 in the place of y. Let y be 0, 0. Okay. Half x plus 2. We transpose the 2. -2 is equal to half x. Okay, then -2, we divide both sides by a half. This cancels. X is equal to -2 divided by half, which is -2 times 2 over 1. Take the divide, change it to multiply. Okay, remember? Yes, that's true. Okay. -2 times 2, so x is -4. So what does that mean? When y is 0, x is -4. Okay, so I repeat again. We use the x-intercept, we let y be 0. 0 in the place of y equal to half x plus 2. We transpose the 2, it becomes -2. We divide both sides by half. -2 divided by half changes to division, changes to multiply. The 1 over 2 becomes 2 over 1. What's -2 times 2 gives us -4. So x is -4. When what? When y was 0. So y is 0, x is -4. Those are the coordinates of the x-intercept. Let's go and find the y-intercept. Okay, because we found the x-intercept, let's find the y-intercept now. We let x be 0, y is equal to half. In the place of x, we write 0 plus 2. What's half times 0? 0 plus 2, which is 2. So y is equal to 2. When x is 0, y is 2. So these are our coordinates for the y-intercept, whereas these are our coordinates for the x-intercept. So since it's the dual intercept method, in that Cartesian plane of mine, all I need is to represent the y-intercept and the x-intercept. The y-intercept, 0 and 2. I know 0 for x is everywhere on the y-axis, and then 2 I can just write there. That is my y-intercept. Then what about my x-intercept? Negative 4 and 0. Negative 4 would be somewhere back here, and then the y value, that is 0. That's everywhere on the x-axis. Okay, so this is my y-axis, this is my x-axis, and all I do is I connect these 2 points. Take a ruler, straight line, connect those 2 points, and then I have my thingamabob. Please guys, use a ruler. Extends a bit beyond. Okay, and that's it. And remember guys, this is the y-intercept, remember, because 0 and 2 this is the y-intercept. This is the x-intercept, negative 4 and 0. When we let y be 0, it means we are dealing with the x-intercept, where the graph cuts the x-axis. It cuts the x-axis there at negative 4. Where the graph is, the x value is 0, then we are dealing with the y-intercept. So that is where the graph cuts the y-axis here. We connect those 2, and then we label y is equal to half x plus 2, and that's done. Okay, and yes guys, you could write negative 4 and 0. That's negative 4 and 0, that point, and this point here is 0 and 2. That's that point. Done, finished. And that's the equation of the line. Okay, but if you write this 2 and this negative 4, and you connect the lines, and you draw the arrows at the end to show that this graph continues infinitely in that direction, that's enough as well. You'll get full marks. Okay, yes guys, you'll get full marks, because here you are just, when you are using the dual intercept method, you are using 2 intercepts to basically find the 2 major points where the graph cuts the y-axis and the x-axis, and then you're just connecting those 2, and that's it guys. Because this is not point by point, this is not the table method using point by point. We are using the dual intercept method to sketch the graph. So the marks, you will get all of them. 1 mark for the y-intercept, 1 mark for the x-intercept, and 1 mark for the direction of the graph. It is an increasing graph because the gradient is positive. The gradient is positive half. So it should be, when the gradient is greater than 0, it should be an increasing line. So our shape should be like that. 1 mark for the shape, 1 mark for marking the x-intercept, 1 mark for the y-intercept, 1 mark for the x-intercept. That is 3 marks, or sometimes 4 marks, including the calculation. So please guys, do not do this. Okay, the plane is definitely going up, Kelvin. It's going to a sweet place somewhere up there, you know, somewhere up there. Okay, let's move. The other things are calling. Hey, 2.5. We're done with 2.4, 2.5. Neha, you're going to Korea. Okay, Korea is it is guys, Korea it is. 2.5 says determine the equation of the graph below in the form of y is equal to mx plus c if a is 3 and 4. All right, if a is 3 and 4. Now I think the other thing that basically we can see from the graph is that you can see that the point A is there, it's labeled. Okay, I'm sorry guys for the visual. The point A is labeled there with blue. Okay, then the graph seems to also pass through the origin. Okay, what do I mean by the origin? It passes through 0 and 0. Right, let me just explain what I mean by this. Okay, this question is a bit clever, and sometimes if you are not someone who is vigilant, you may miss this point. This is an increasing straight line. It's like that. They've marked A, and then they told us that A is 3 and 4. But the graph also passes very discreetly. It passes through this point here. We call this, guys, the origin. The origin is the point 0 and 0. And the people often miss that this is another point that we can utilize to be able to find the equation of the straight line. So now we are asked to find the equation in the form y is equal to mx plus c. What do we need in order to find the equation of a straight line? We need the gradient. In other words, we need to find m, and then we need the what? We need the y-intercept. Okay, y-intercept, so that we can be able to know what the c value is for our straight line. So I'm sure you guys can see already what the equation of the straight line could be, because look at the graph, it's cutting through the origin. So its y-intercept, if we were to be honest, our y-intercept from the graph is actually equal to 0, because the graph is cutting through the origin. Okay, its y-intercept is 0, which means this c value is 0, simply put. All right, so if you are someone who's doing this question, there's actually really those two ways that I explained even earlier on to find the equation of the straight line, and I'm sure you guys can use those methods. You can either substitute the y-intercept there and then substitute the given point and find m. All right, and then write the equation. Or you can use this origin and this point to find the gradient of the straight line using m is equal to y2 minus y1. And then after that, when you are done finding m, you can then substitute another point and find the value of c. How to find x-intercept? Well, to find x-intercept, you let y be equal to 0. If you want to find the x-intercept, you let y be equal to 0. Okay, so do both ways. All right, let me show you then how you would do this. You can either do it this way, y is equal to mx plus c. You can first, like I said, in order to find the equation of the straight line, you need the gradient and the y-intercept. That's what you need. You need these two things. If you have these two things, you are good. Okay, if you are given them, you can just substitute them, m and c. M is the gradient, c is the y-intercept. But if you don't have them, okay, if you don't have the gradient and the y-intercept, you can find them. So for instance, I'm going to find m. How? Because I have a, which is 3 and 4, and I have the origin, that point. It is not, I know that when the graph passes through there, that is the origin, and the origin, the coordinates of the origin are 0 and 0. I know that intuitively. You must know that intuitively, guys. If you don't know that, then it's very easy to not get this mark, because you don't know that the origin is 0 and 0. So let's go. I'm doing all 14 pages today. I don't know. We'll see. So let's go. Point 1, we can say x1, y1. Point 2, x2, y2. Okay. x1, y1, x2, y2. Okay, so if I now find the gradient, okay, if now we can find the gradient, y2 0 minus y1 4 over x2 0 minus x1 3. 0 minus 4, negative 4. 0 minus 3, negative 3. Negative divided by negative, positive. Gradient 4 over 3. Does it make sense if we look at the line? Yes, it does, because this is an increasing straight line. So does this gradient make sense? Yes. Guys, I love it when learners are able to make sense of this gradient that they get in relation to the line that they have. So you're making sense. Oh, okay, I get 4 over 3. Okay, is this 4 over 3 correct? Because you could make an error, a simple error of making an error with the signs, right? So you get 4 over 3 is positive. Then you now reconcile. Is this positive 4 over 3 making sense if I look at the shape of the graph? Yes, it's positive. It's an increasing line. So gradient is 4 over 3. Then you say y is equal to, remember, you wanted m, now you have him. So you say 4 over 3x, 4 over 3x plus c. You don't have c, right? But what do you do to get c? You substitute. What do you substitute? The other point. Which other point? The origin. All right? You can substitute the origin, or you can substitute 3 and 4. It's really up to you. Doesn't matter. You will get the value of c. Okay? So if I decide to substitute 0 and 0, what happens? Y is 0 is equal to 4 over 3. X is also 0. Plus what? Plus c. What's 4 over 3 times 0? It's 0. Okay? Plus c. That means c is equal to what? 0 minus 0 gives you 0. Therefore, what does it mean? In the place of c, what do I write? Y is equal to 4 over 3x plus 0. But I can simply write this as 4 over 3x. Remember that this x is not in the denominator. This x is in the numerator. So you can write it in line with the division sign. Okay? Please, so that it shows that it is the variable. 4 over 3 is the coefficient. Okay? Okay? So hopefully we can see that. Okay? That you can first find the gradient using the what? The gradient formula. After using the gradient formula, once you have the gradient, you can then substitute one of these points into the equation of the straight line and then calculate the value of what? Of c. Okay? And then after that, you are able to write down the final version of the equation of the straight line. Remember, your equation was missing m, it was missing c. Now you have m there. Y is equal to 4 over 3x. Now you can substitute, all right, c as well because you have it. Could you have used the other point, 3 and 4? Definitely. Let's say we were writing the same thing. Y is equal to 4 over 3x plus c. But then we decide to substitute 3 and 4. Could we substitute and also get the answer? Definitely. What's y? Okay. What's y? Y is 4. What is x? X is 3 plus c. Now 4 over 3 times 3. You could use your calculator and say 4 over 3 divided by 4 over 3 times 3. Okay. So the 3 and the 3 cancel. We are left with 4. Guys, I know it's past 12. I understand that, but I'm going to just see how far I can go, and then I'll sleep just whenever I'm done here. Then you take the 4, okay, over c is equal to 4 minus 4. Does that make sense? You're welcome now. Okay, c, you take the 4 over 4 minus 4. What's 4 minus 4? That means c is equal to 0. Do you see that, guys? You still get c is equal to 0 even if you substitute this point instead of this one. What I'm saying is that as long as the point lies on the line, you can substitute it and it should be able to give you the same answer. Okay? Same, guys. Okay? Yes. After I'm done with the live, I save and I upload it onto the YouTube channel so that people can rewatch this at their own time. Okay, yeah. Okay, now I hope that's clear. All right, so this is how we find the equation of the line. All right, we found it. Y is equal to 4 over 3x. Okay, might have sounded difficult, but it was not as difficult as link is in my bio, guys, for the YouTube channel. Link is in my bio. Okay, link is in my bio. All right, now I'm done with those graph questions. It seems like geometry is following up. Okay, please do when we don't have the coordinates but we are given a linear graph. Please do when we don't have the coordinates but we are given a linear graph. Guys, this was a situation with the linear graph. Remember, if you have to go to the graph itself and look at the graph and see if you can't see a point that is aligned with the x values and the y value. There must be somewhere where you can locate the points. Yeah, well, there must be somewhere that you can locate the points. So unless you guys have an actual example, because I'm not sure if I understand one where you cannot so let's move. 3.1, given below xy is perpendicular to AB, determine with reasons the size of XBA. XBA, come on, tell me, guys. XBA, given below xy is perpendicular to AB, determine the reasons the size of XBA. Okay, you're saying 90 degrees. What's the reason? What's XBA? What would be the reason? You are right, XBA is equal to 90 degrees. Okay. All right, so I'm hoping those who are watching okay. I see a lot of people saying complementary angles. Okay, I see a lot of people saying complementary angles. Okay, this was XBA. The y was there. Yeah. So to be honest, personally, given below, determine the reason the size of XBA. So yes, XBA is equal to 90 degrees, no doubt. Yeah, and remember, they actually did say, remember, perpendicular means that this angle is 90. It also means that angle is 90. So to be honest, I personally would probably say that it's because XY is perpendicular to AB. That's what I would say, okay? Is the reason why XBA is equal to 90, okay? I would say that, because remember, that is 90, but that also implicitly is actually 90 degrees if you basically have XAB being perpendicular to XY, all right? So perpendicular lines implies that these angles each are 90 degrees, okay? I hope that makes sense, okay? All right, let's go on to the next one. Where? Here. Okay, here. Okay, can you guys see 3.2? AB intersects CD. The word intersect means cut through, overlap. So AB and CD overlap each other, but they are both straight lines. They are line segments. So AB intersects CD at what? At X. And then they're saying calculate the value of what? The size of Y. So you have 87 degrees, and 87 degrees has a relationship with y plus 30 degrees. What do we call those angles, guys? We'll calculate the size of y. How would we go about calculating the size of y? Okay, Suti, angles on a straight line with x? No, Suti, definitely not. Okay, vertically opposite angles. Thank you. Super, not angel, you're 100% correct. Neha, you're 100% correct. Dalav, you are very, very good. Osi, yes. UK Senati, very good. Neha and Bali. Guys, the relationship, okay, cross, at the cross. Yeah, at the cross, I bow my knee. So the y plus 30 has a relationship with 87 degrees. But that relationship is not angles on a straight line. These angles are vertically opposite, guys. Okay, vertically opposite. This angle will be equal to that one. Vertically opposite. Remember, angles on a straight line, it would be this angle next door to this angle. It's adjacent angles on a straight line that are adding up to 180, but vertically opposite angles are equal, guys, please. Okay, no, Suti, no, Suti, you're confusing two things here. Suti, listen to me. If this was y plus 30, let me show you an 87 like this, right? Listen, Suti, from here to there is y plus 30, and then from here to there is 87. If you are looking at this line, these two angles share this common vertex, and because they have a common vertex, they are next to each other. We say they are adjacent to each other. They are next to each other. And because they are next to each other, sharing a common vertex, these two angles complete 180 degrees. They are straight line angles. From y plus 30, which is from here to there, and then from this point from here to there, they complete 180 degrees. They are next to each other. They lie on a straight line. These add up to 180 degrees. These are angles on a straight line. They are not equal. We say these two angles, if we add them, they give us 180. But these ones, so 87 degrees and y plus 30, these are vertically opposite angles. Okay, please, you must differentiate between those two. When you do, then it will make life easy for so y plus 30 degrees is equal to 87 degrees for this one. Y vert op angles equal. Then we solve for y. And you will see there are beautiful people in this beautiful world that we are in that solve beautiful problems very beautifully and simply. Okay, so y plus 30 is equal to 87. Then we say 87 degrees. Okay, minus 30 degrees, which means y, as Magabaza 58 says, is equal to 57 degrees. Calvin Lolwana is saying the same thing. And there we have it. So statement, 1 mark. Reason, 1 mark. Calculation, 3rd mark. 3 marks. Straightforward. Okay. Now imagine if you make the mistake of thinking these are angles on a straight line. Please, guys, differentiate. These common vertex complete a straight line. This is next door to him. We add them together. Protractor from 0 to 180. We add them together. They are 180 degrees. Reason, angles on a straight line. That's what we would write. If I was doing this problem for instance, and it was saying solve for y, we would say y plus 30 degrees for that one plus 87 is equal to 180 degrees. Then we'd say angles on a STR line. Yes, super not angel. Or you can say adjacent angles on a straight line. That's also fine. Okay, then what do you do after that? The 30 and the 87, you take them over to the other side. You say 180 minus 87. How do you know to subtract? Because this is positive 87. When 87 crosses over the equal sign, he changes from positive to negative. If this 87 was negative and it was crossing over, it would change from negative to positive. He changes when he crosses over, being a separate term from other terms. Okay. You see? Yeah. Then you would get the answer, which I know some of you will be able to get. Okay? Please, guys. Please, please, please. Okay, now, if you make a mistake on the last answer, but the rest calculates right, what will happen? You will lose a mark for the answer. That's what will happen. You lose a mark for the answer, which is painful. Okay, so if you know that you have a tendency of not writing answers correctly, please let your calculator be very close to you and accessible, and make sure that you punch in the calculation one time and then you confirm and double check again, and you punch it in just to make sure that your answer is really the one that is supposed to be there. And please don't take for granted when you are putting in numbers in your calculator. Make sure that when you put in the numbers in your calculator, you are making sure that if it's 87, it's 87. If it's 30, it's 30. You don't want to be writing something and thinking you are writing it, but you are writing the wrong thing, or you are punching in the wrong thing. Okay? Yeah. Right, let's move on to the next one. In the figure below, what a beautiful figure, by the way. Okay. What a beautiful figure. Woo! So beautiful. All right. Can you see that figure? A plus 30 degrees. Yes, 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 yes. P, T, A, 2A. Oh, sorry, my figure is messed up. Sorry, let me just redraw that. P, T, A. Okay. A plus 30 degrees. A, P, T, 2A, R, Q, S. All right, so what do they want from us? In the figure below, they are saying PT is parallel to QS. And then PQT, what do they mean by PQT? PQT, they mean the angle PQT is A plus 30. That's already in the diagram. They've already written it down, so we are good. Then angle T is equal to A, right? Then angle RQS is 2A. Complete table below to determine the value of A. Complete the table below. So let's complete it, guys, because they want us to complete the table. Angle TQS is equal to, they've already written the reason for us. That reason that they wrote, guys, I hope you can see that they wrote the parallel lines and they said alt angles. So we need to just check now. TQS, what does alt angles refer to? It refers to that N or Z effect. That N or Z, those angles that are there in the Z shape. Very good. So TQS, can we see TQS? Hopefully we can see TQS. What is TQS equal to, guys? Because it is the Z or the N shape. Love angle A. Very good. Yes, it is A, guys. Angle TQS is equal to what? To A. The reason is already provided. It's just that we are used to saying alt angles first, then we follow it with the parallel lines. But we will forgive those people. Okay. I like that you do that, Neha. Using a highlighter to mark the shape. That's beautiful. All right. You do something like this, Neha, and I love that you said that for the benefit of the masses. Okay. Okay. I've got some markers here. So you see, TQS. It's this angle, this one. You see, this one, this guy. You see, but if you complete a Z, look at that. You see, so it's this angle that's equal to TQS, this one. Okay. So I hope you understand. TQS is equal to A. And our reason for saying that alt angles PT is parallel to QS. They started with the parallel lines, but guys, let's just make sure we are able to have that full reason. Then the next thing, A is equal. So they want us to find the actual value of A, and they want us to give a reason. All right. So what I like doing personally is making sure that when I get an answer, I then fill it in, where I've gotten TQS. I update my diagram. Update. It's like updating your phone. You see, you update your phone so that it can operate in a reasonably better fashion than in the past. Now this diagram can operate in a fashion that will assist me to find the value of A. Guys, what do you see here? We have 2A, we have A plus 30. Now this is the time when I wish I could call Mrs. Engels on a straight line. Is Mrs. Engels on a straight line still here? Who was Mrs. Engels on a straight line again? Mrs. Engels on a straight line. Where are you? Mrs. Engels on a straight line. Do you guys still remember Suti? Suti was Mrs. Engels on a straight line. I don't know if Suti is still here. Okay. But this is a straight line, guys. Okay. Yeah, this is a straight line. And going back to this idea of saying angles on a straight line, the common vertex is Q. You see, Q is the common vertex. This angle plus that angle plus that angle, what do they complete? They complete a protractor, a straight line. They complete 180 degrees. From 0 to 180, the straight line is PQR. Are we together, guys? Do you see? And do you see the importance of updating my diagram? Updating my diagram with the information. Okay? Guys, please. Okay? So then we can say 2A plus A plus who? Plus A plus 30 degrees is equal to 180 degrees. And all we simply do is say angles on a straight line. And guys, maybe some of you are like, why is this guy using this angles on a straight line thing? Guys, the thing is, there is a document that examiners use, which is called the exam acceptable reason document. It's in the exam guideline. You can find it online. So this reason here is an acceptable reason. In actual fact, guys, let me just say, when I write down reasons in my live sessions, I don't write reasons that are just thumb-sucked or have been learned from others. I'm using the official reasoning that is found in the exam guideline, or the acceptable reason document that is utilized in the exam guideline. So this angles on a straight line is an acceptable reason that is there. Okay. Yeah. But here, this is what we use. If you are going to say interior angles of a triangle, all right, it would have to be that first you find this angle. I mean, that's what you would have to first do. This is 2a, which means angle P is also going to be equal to 2a. You would first have to write that down. Say angle P is equal to 2a, and then you would write the reason. Correspond angles, and then you state the lines that are parallel. PT is parallel to QS. You would have to start there first. So then you get the 2a, then you can use the interior angles of a triangle. Remember, there are steps that you would have to first move along. Remember, this is bottom of this parallel line, bottom of this parallel line. You get that angle, and then you add the 3 angles. You must not forget the parallel lines, guys. You must not forget. Is it necessary to state the parallel lines? Absolutely. Failing to state the parallel lines is basically shooting yourself in the foot, because your reason is not complete until you state the lines that are parallel. That's what gives your statement power. Okay? Yes, Neha, it's the base of your cake. It is the yin in the yang. All right. So 2a plus a plus, you see? So you can use, once you use corresponding angles, then you can use sum of angles in a triangle, or interior angles of a triangle, or angle sum in a triangle. You will still get the same answer for a, because you can see these values, these angles in terms of a are the same angles in terms of a you are using for angles in a straight line here, and you will get the same answer fundamentally. What if we weren't told that the lines are parallel? If we weren't told that the lines were parallel, they would obviously have written the symbols that indicate that the lines, that they are parallel. All right? Or if you have not been told that the lines that they are parallel, something in the statement must be stated that would help you in concluding that those lines are parallel, or you would have to first prove that they are parallel. Okay? No, Makabaza. If you say angle P is equal to angle Q, if you say angle PQ are equal, reason being base angles of a triangle are equal, am I? No. Makabaza, we don't use base angles of a triangle. We don't use that reasoning. Okay. By the way, P and Q are not equal. They absolutely not equal, right? And even that reason of base angles, remember this thing of base angles, if ever you have an isosceles triangle like this, and this is angle A, P, and Q, and let's say you are told this is 30 degrees, you say angle Q is equal to angle P, and you say they are equal to 30 degrees, but you can't say base angles of an isosceles triangle. You have to say angles opposite equal sides. That is the reason that we use angles opposite equal sides for when you have an isosceles triangle. But base angles of an base angles, we don't use that reasoning. It is not an acceptable reason. Okay. Now let's go and add the like terms. 2a plus a plus a. Remember, there's a coefficient of 1. You can't see it. It's like God. We say he's there, but we can't see him, but he's there. So 2a plus 1a plus 1a. You keep the variable because it's a, but then you add the coefficients. 2 plus 1 is 3 plus 1 is 4, so that's 4a. Okay. You state lines. You see now, Nancy, it means like you came along in the process. When do we state lines are parallel? If we have the F shape for corresponding angles, top angle is equal to top angle, that's corresponding angles. If you use corresponding angles to find an angle, then you must state the lines that are parallel when you write your reason. You must state the lines that are parallel. For co-interior angles, the sum of the angles, the armpit angles, they add up to 180 degrees. When you write that reason co-interior angles, you must state the lines that are parallel. And then lastly, for N shape, if you say these are alternate angles, they are equal, you find that this is 30 and that is also 30 alt angles, you also must state the lines that are parallel. We always state lines that are parallel for these important ones. After getting 4a, you take the 30, you transpose. Plus 30 becomes minus 30 on the right side. You get 150. Okay. Then you divide both sides by the coefficient of a, which is 4. So what's 150 divided by 4? You get a is equal to, what's 150 divided by 4, guys? Okay. Okay. Some are saying 25, which is nonsense. You can't say a is not 25, guys. Guys, you are asleep, you guys. 37,5. Thank you so much. 37,5 degrees. Okay. Yes, decimal places, 37,5 degrees. Please, very good. Okay. All right. Yeah, I think that basically was a nice problem there. There's another one. In the diagram below, DF is a straight line. There is DF. DF. And they are saying AB is parallel to PQ, as you can see there. So AB is parallel to PQ. And then they're saying EG is perpendicular to DF. EG is perpendicular to DF. And then they seem to have some extra information there. All right, I believe you have a Z there, you have an X. Okay, a Z at the top of that straight line where the angle C is. And then you have a D, and then you have F. So AB is parallel, as it says, to PQ. They even have the parallel symbols. 35 degrees, and then they have F, and they have G. Look at Pales as saying go to parallel. Like you people, I'm telling you. No. And Pales is just saying let's go to similarities. I'm struggling. Yeah, I think some of you feel you are so entitled. I'm sorry. I don't really respect much of what you guys. Your generation is very entitled, right? You could swear Palesa is paying me loads of money to basically run this live. No asking, no please. Let's go to similarities. I'm struggling. That's entitlement at its best. I think we need to fix some of these attitudes that we have here. It's not a good attitude. I'm sorry to say. Anyways, so let's go. It says determine the size of y, the size of z, and determine the size of x. Okay, so what I did here, very good, Magabas. Already seeing angles on a straight line, very nice. Okay, I think I'm seeing it too. Okay, and I've seen that. Neha, you're probably the most appreciative person that I've seen in this life, and you've been raised well. You must give your parents a high five for me. They've done a good job with you, that's for sure. Or at least you have internalized what really matters when it comes to human relations. It's something that's very much missing in the generation of kids that we have today. Very entitled, so entitled. Okay, so I just kind of read through this, okay? Because they want y, they want z, they want x. So what I want us to, y, z, and x. So if we look at y, we have 3y minus 20, we have 35, we have this 90. Okay, and I remember someone said they've seen angles on a straight line. Thank you so much, Batman, for the heart me. Yeah, not super, not angel. I love that. Okay, there's different things people are seeing. So for instance, let's look at Makabaza said sees angles on a straight line. Now this 90, this 35, and 3y minus 20, very good. You guys are 100%. The common vertex is there. So you can take 90, which is next to 35, which is next to 3y minus 20. You can use these 1, 2, 3 angles to solve for y. Very good. Makabaza, good thinking. Super, not angel. Thinking differently. You are thinking of complementary angles. That's 100% as well. You're saying 3y minus 20 plus 35 together should give you 90 because we were told that this line is perpendicular to that one. So definitely, if you do not use angles on a straight line, adding these 3 angles, since they share a common vertex and they are next to each other and they lie on a straight line, you could use the addition of these two equated to 90 degrees and say complementary angles. Because you see a what? A right angle here, which means there's also a right angle there. Right? So 2 ways of getting y. You could use the addition of the 3 angles. 3y minus 20 degrees plus 35 degrees plus 90 is equal to 180 degrees. Why? Angles on a STR line. Okay, that's a way to get the value of y. And I'm sure all of you see that. Okay, look at this. This 90 crosses over, becomes minus 90. This plus 35 crosses over, becomes negative 35. This negative 20 crosses over, becomes positive 20. I am doing this so that those who are wondering, when does the sign change? Please, guys, take note. There are 1, 2, 3, 4 terms on the left-hand side. The y term is just 3y. So this needs to be isolated on the left. The negative 20 transposes to the right. It becomes positive 20. Positive 35 becomes negative 35. Positive 90 becomes negative 90. 180 was positive on the right. It stays like that. Then you use calculation. You get the value on the right hand side. 180 minus 90 is 90. 90 minus 35 is 55, and then 55 plus 20 is 75, and then 3y is equal to 75. You divide both sides by what? By 3, and you get y is equal to who? 25. Very good, guys. Guys, 100% on point. Another person who decided to add these 2 angles instead of adding all 3 and then say equal to 90 degrees and then says comp angles. You are 100%. Complementary angles. Very good. Why? Because that is already 90. You know that. So that means the addition of these 2 is equal to 90. The addition of these 2 alone, because this 90 degrees, okay, there's another 90 this side because of the fact that we were told that these lines are perpendicular. So you can say 3y minus 20 plus 35 is equal to 90 degrees. Reason, comp angles. Comp angles means complementary angles. Then you solve for y, guys. 90 minus 35 plus 25 is 75, and then you solve for y. You get the same answer for y, which is 25. This is a different person compared to this person, but both ways are very good. Yeah, doesn't matter which method, Batman. Doesn't matter which method, because the method must just have a good statement with a accurate reason. Comb angles, complementary angles. This one, we added the 3 angles and then we said equal to 180 angles on a straight line. Statement 1 mark, reason 1 mark, simplification and answer. Statement 1 mark, reason 1 mark, simplification and answer. 4 marks, guys, that you get just for doing your calculation 100% correct. So when we have, you thought it was 20, not 25. How? Hi guys, come on. But now if we're making these silly mistakes at the end, it means we are going to be constantly losing marks at the end. Okay, we're constantly going to lose marks unnecessarily. Yes, calculator, thank you, super, not angel. Tell them, girl, tell them. Right, so now we know what y is. What do we want now? We want z and x. Okay, very good. Head calculation. We want z and x. Now, what do we know about z and x? Someone is saying co-interior. So the one who's saying co-interior is looking at this, the armpits. Okay, we can say z plus this guy together give us what? 180. Z and this give us 180. Very good. Okay, so someone who's thinking that, you are good, 100% correct. I see someone else saying alternate angles as well to get x. Very good. This, okay, I love this. Let's just use different so we can see the u. Want to see our armpits where it stinks? Okay, this is where it stinks, guys. So remember, when it stinks, we add roll on. We add the 2 angles. These are not angles on a straight line. The z and the 3y minus 20 are not angles on a straight line, guys. These 2 angles are co-interior, U-shape, because these are parallel lines. Very good. We can use that. Okay, co-interior angles. Okay, co-interior angles. Okay, remember, guys, whether they're pointing at B and Q, this line and this entire line and this entire line are parallel lines. Okay, yeah, okay, I hope that makes sense. Okay, so we can use co-interior. So we can say 3y minus 20 degrees plus z is equal to 180. Then I can say co-int angles, and then I state the lines that are parallel. AB is parallel to PQ. Okay, does that make sense, guys? Yeah. Then remember, I got y is 25, so I'm going to substitute y in the place of y. I'm going to substitute the 25 that I got in the original, in the previous question. You see, because this was a nice build-up. Take the 25, go and substitute in the place of y so that I can solve for z. Okay, minus 20 degrees plus z is equal to 180. Okay, and then 75 degrees minus 20 plus z is equal to 180. We transpose everything now. 180 plus 20 minus 75 is z, and what does that lead to? 180 plus 20, 200 minus 75, 200 minus 75, 125. Thank you so much. So z is equal to 125 degrees. Update. You see, update. Update. Z is 125. There it is. Z is 125. Then when I have the 125, I can use also, if I wanted to, angles on a straight line to get x. Guys, it would be easier even. All right. Okay. You could use alternate angles because you already have y. You can say 3y minus 20 is equal to x. and then you write alt angles, and you state the lines AB is parallel to PQ, and you solve for X. Okay. Yeah. But yeah, someone else was saying we could have used corresponding angles to find Z. You are 100% correct, because this 90 plus this 35 is a top angle, and then this one is also a top angle. On this parallel line on top, on the same side of the transversal line, on this parallel line on top. So 90 plus 35 would be equal to Z, and I could say Z is equal to 90 plus 35. Reason, corresponding angles, and then I solve for Z, I get 125. So there was someone who said corresponding angles, 100% correct. That could have been another way to find the angle Z, the F shape. You saw F2, very good. Guys, this is what I love. Once you train the geometric eye, training of the geometric eye comes with practice. The more you do mathematical problems that have to do with these concepts you are learning, but the less time you spend, then it sucks. It's like playing a game. That's why I say maths is a game. I know some of you have become avid game lovers. You've become avid game lovers. In a certain game, you can play it on hours on end, and what has happened over time is you've become a pro at playing that game, and you know when to do what, because you've been spending a lot of time playing that particular game, and you know the controls, you know how to maneuver and so forth. It's the same thing with maths. Maths wants you to first understand the concept. Once you understand it, you must practice, you must play it often, so that you can level up and you can do well. You'll start having a very positive feeling about the maths that you are doing and what you're doing. So that's another way. So 125 plus X, guys. Okay, I'm just going to use angles on a straight line. You can use something else, it works. 125 plus X equal to 180 degrees, angles on a straight line. Okay, maybe you can use something else that will also work. Okay, and then when you do that, the X is equal to 180 minus 125. We know that X is equal to what? It's equal to 55 degrees. Okay, yeah. Anything works. Okay, someone else could have used alternate, it would have worked. Alternate angles, alt angles, PQ is parallel to AB, it would have worked. 3y minus 20 is equal to X. You substitute in the place of y, that what? That's 75 degrees, that 25 degrees. 3 times 25, you get 75. 75 minus 20 gives you that 55 degrees. It would have also worked. Alternate angles. Okay, let me just write it for those. 3y plus 20 is equal to X. Alt angles. AB is parallel to PQ. No, why? Let's go and sleep, guys. If we need to sleep, please don't stay up on my account. I think 75, sorry, minus. You see, now I'm writing plus, making mistakes. Minus, don't forget, minus 20. 75 minus 20, so it's 55 degrees. Okay, so X is 55. It works out nicely there. Nicely done, smoothly done. All right. Yeah, guys, let's see. Okay, that's done. Okay, I think these ones I'm not gonna really go ahead and write down, but I think we can discuss. Yeah, you need to sleep. I need to sleep, but I'll sleep. Don't worry, man. It's just that I'm still fresh. So if you look at this diagram, okay, we have two pairs of parallel lines. You have the horizontal ones that you can see there. Okay. Yeah. So it's very nice to see these things so that you can see them for what it needs to be seen. The question there says x is equal to, they even gave you the reason already, PT is parallel to QS. If PT is parallel to QS, x, there opposite the angle T, vertically opposite to T, the x is there. So if you look at 124, the relationship that x has with 124, what relationship does x have with 124? It's like the F shape, right? Do you see that? And the 124 is on top. The x is also on top for F shape. What does that spell? Corresponding angles. PT is parallel to QS. So that means x is equal to what, guys? It means x is equal to 124 degrees. I hope you understand that. I hope you can see that. X definitely has to be 124, no doubt. Then if you look at y, what is the value of y? Does x, you update your x value most. You get 124, you write it down in your diagram. You know, that's what I would do, update my diagram. So I know that x is now 124. Y, okay, have to get the value of y. But be very careful, guys. Some of you will rush and you will say something that you actually don't mean. Okay, some are saying it has a alternate angle relationship, and I'm saying no, it can't be. It doesn't. Remember, if it did, then it would be this here. This angle has a alternate relationship with y. Okay, so it's not that one. It can't be that one. Okay, so let's be very careful about that. Very careful. Very careful. Okay, there was a t there. No, it's not corresponding as well. This x doesn't have a corresponding relationship with y. Y is here, guys. This is where y is. Okay, do you need me? Do you need a reminder? Thank you so much, Palesa. You're 100% correct. So we can say this T, okay, P, T something, all right? So if we go back to the diagram, this is very important. Yeah, PTO. Yeah, we must write the angle properly. Angle PTO. Angle PTO. I repeat, angle PTO. Angle PTO is equal to what? 124 degrees. Why? That op angles equal. Then from there, I update. I know this 124 and this y, they have a relationship. They have a relationship, these two angles. They are co-interior, U-shape. Okay, so the y plus the 124 degrees should give me 180 degrees. What's the reason? Co-int angles. Why? TD is parallel to AB. So then that means y is equal to 180 minus 124 degrees, which is actually equal to what? 56. Is it 56? Yes. Yeah. All right. Then lastly, the last thing, this is Z. Yes, Z is alternate. So this is 56 degrees. So my Z is equal to 56 degrees. Reason, alt angles. Which lines are parallel? Remember, if it's this angle and that means PT is parallel to RO. So Z is equal to Y, definitely. Z is 56 degrees. Okay. All right. I think that's that for that. I just want to see what other questions do we have here. Okay, I think we have a triangle type question that follows this one. Triangle question. Okay, this one. Given the triangle XYZ below, determine the length of Y. XYZ below. XYZ below, determine the length of Y. Thank you. Bye Neha. Bye Neha. Given the triangle XYZ below, determine the length of Y. What would be the length of Y? Thank you. Yes, guys. The length of Y is equal to 7 centimeters. What's the reason? Y is definitely equal to 7 centimeters. Do we know why? What's the reason? And I hope we write the reason right. What's the reason? I want the reason. Because we must give a reason for the 2 marks to be awarded. No, it's not isosceles triangle. Guys, the reason isosceles triangle doesn't work, it's sides opposite equal angles. Sides opposite equal angles. Okay, remember we identified sides opposite equal angles. Okay, if you have angles that are given to you that are equal and you are asked to find a side, you are already told that these angles are equal. Then you say the sides are opposite angles that are equal. So that is why you are going to say Y is equal to 7 centimeters as well, because these 2 sides are opposite angles that are equal. Okay, sides opposite equal angles. The reverse is true when you are asked to find a missing angle, but you are told that the sides are equal. Then here we would say X is equal to 30 degrees for the angle, but then we'd say angles opposite equal sides. We don't use isosceles triangle as a reason, or base angles of an isosceles triangle. We don't use that, guys. We must use this because this is the acceptable reason that's in the acceptable reason document. We must get acquainted with using these appropriate acceptable reason. Angles opposite equal sides. All right. I'm just giving you tips for people who want to do maths in grade 10. Familiarize yourself with these guys. You will already set good habits for yourself for the future. So like I said again, if it is an angle you are looking for, you are given the sides that they are equal. Okay, you are tempted to say isosceles triangle. Please don't. You say X is 30 degrees, that angle, but you say angles, both of them are opposite sides that are equal. So angles opposite equal sides. If you are given angles already that are given to you, that they are equal, and you want to find a side that is missing, that is opposite those angles that are equal, then you must say Y is 7 centimeters, or Y is equal to that side, sides opposite equal angles. Okay, so please guys, I think that particular shape, that one that we were looking at, I'm sure you could see it is not an equilateral triangle, it is an isosceles triangle. So we use the reasoning that I have sort of like advised you to use. Okay, for your own sake and for your own good, do that. In the diagram below, AC is equal to CE, angle A is equal to angle E. Prove that triangle ABC is congruent to triangle DEC. In the diagram below, AC is equal to CE and AE is equal to, angle A is equal to angle E. Prove that triangle ABC is congruent to triangle DEC. Okay. So congruency, guys, I think I explained earlier on today that there are 4 cases of congruency. There's side, 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 there's side, angle, side, there's angle, angle, side, and right angled hypotenuse side. In other words, RHS. So in this situation, you already have a pair of corresponding sides that are equal. So I'm just going to write those down. AC is equal to CE. Already that is given to me. And then also angle A is equal to angle E. Already that is also given to me. And then the last thing I can say is that angle C1 is equal to angle C2. Why? Vertically opposite angles are equal. And then I conclude, therefore, triangle what? ABC is what? Congruent to triangle what? DEC. Now I want to show you something. What did I identify? When I said AC is equal to CE, that's a side. When I said angle A is equal to angle E, that's an angle. When I said angle C1 is equal to angle C2, that's another angle. That's a case of congruency. So that means triangle ABC is congruent to triangle DEC. South African Airways, ooh, we are flying out of here, flying to level 7, ooh, flying to level 7. Yeah, funny stuff, eh? All right, so hopefully that makes sense. Okay, that's for those kids that know flying to grade 10, yeah. If those kids that know that they will actually be doing congruency, and it will be actually tested for them tomorrow. Let's move on to the next situation. That's a congruency situation done. Look at this one. If triangle ABC is similar to triangle DEC. So guys, here we are told that two triangles are similar. Okay, H is asking, isn't it supposed to be in the middle? Guys, you see now you see, I went through cases of congruency and people are saying things that, H, these are the 4 cases of congruence. SSS, that's when you have 3 corresponding sides equal. SAS, we said if there are 2 sides and there's one angle, the one angle must be in the middle. In what we've just done, there was no one angle, there were 2 angles, meaning case 3 was the situation. Side, angle, angle, or you can have angle, angle, side, or you can have angle, side, angle, okay, because that's feasible as well, okay. One of these 3 supports case 3. And then lastly, RHS, right angled hypotenuse side. Please, please take note of these cases and the order. Yes, this one, I said the angle must be in the middle, but remember, what we've just proved is this one. Right? Please. Oh, taking me back now. Taking me back. Right. So, let me go back to my similarity situation here. We are told if triangle ABC is similar to triangle DEC, determine the size of X. Guys, we are told, it is stated to us the 2 triangles are similar. We don't have to prove them. We are told that they are. If triangle ABC is similar to triangle DEC, determine the size of X. So remember, what did I say? Okay, what did I say about similarity? I said, the minute we are told the triangles are similar, what can we conclude, guys? If the triangles are similar, then it means the sides can be written in the same proportion. Here, there's no need to prove anything. We are told that if they are similar, we must actually find out what X is. So I'm just going to redraw this. Okay, so I'm sure you can see if triangle ABC, I want to show you this is similar to triangle DEC. Okay, guys, if the 2 triangles are similar, then listen, then it means the sides are in proportion. I like what Supernode Angel has said. Then it means the corresponding sides are proportional. They are. So based on this, the eyebrows apply. Eyebrow number 1. AB over DE applies. But I don't write them separately. I write them being equal. Okay. Yes, thank you. Sorry for not acknowledging you. You said it too. Very good. Owi. Is it Owi? Thank you so much. You keep him starstruck. Thank you, Lux. So AB, BC over EC. Smile after the eyebrows. AC over DC. The reason, similar triangles. Okay. Now, let's go here and check. Which two will we choose? Okay. Remember, we choose the two that have info that we can use. We don't choose the ones that do not have info. So for instance, we want X, so that means where AB is, we are going to have to take the one that has AB. So when we are choosing you, whether you like it or not, you are coming along with us. You are under arrest. Now let's look at BC. Where's BC? BC is here, it's 2 centimeters. Where's EC? EC is here, it is 9 centimeters. Where's AC? AC is here, it is 3 centimeters. Where's DC? DC is here, it is 6 centimeters. So you know what? It means we can choose any of these two. It's up to you. So let's say one learner decides to say AB over DE is equal to BC over EC, and we are going to see if it will work. Let's say the other learner decides to take AB over DE is equal to AC over DC, and what we want to see is, will we get the same answers with these options? Now AB, what's AB? AB is X. What's DE? DE is 12. BC, what is BC? BC is 2. Ne? What is EC? EC is 9. Okay, make sense? Let's come here. AB over D is X over 12, of course. Then what is AC? AC is 3. What is DC? DC is 6. Okay, I just want to confirm something here. AB over DE, all right? BC over what? EC, BC over what? EC. Okay, and then lastly, AC over what? DC. Yeah, something is definitely wrong. You're right, Supernal Angel. What's wrong? What's wrong? Is it the diagram? Let me just go back. Something is absolutely wrong. I thought I was the only one. Yeah, I think the diagram. Because if ABC is similar to triangle DEC, then it should size up very nicely. But it doesn't size up, does it? It doesn't size up. Yeah, we shouldn't. It's true. So I can tell you this one thing. I guess the thing that is making it that the answers are apparently different. 2 times 3. Whoa. But if they are similar, right? A, B, C, D, E, C. Okay, what is wrong, guys? Because if you times, what is it? If you times 3 by 3, you get 9. If you times 2 by 3, you get 6. If you times, it should be CED, or the order of the triangle should be different. Oh, so they've given us the order wrong. Yeah, I think then that would have been an error from the question. Okay, CED. Okay, right. Okay, let's just rewrite our ratios using that then. AB, thank you so much, OE. Is it OE? Yeah, you need to tell me your name. AB over C. But it's still a problem there. AB over CE. But I think, guys, you get the point, right? Yeah. ACD. The point, though, the point. DC. Do you guys get the point, though? Man, is it DCE? No, it can't be DCE. You get the point, right? Because if I guess you can get the answer intuitively, right? You could get the answer intuitively. What did they do to the 3 to get the 9? They multiplied by 3. What did they do to the 2 to get the 6? They multiplied by 3. Or vice versa, in reverse. You could say, what did they do to 3? What did they do to 9 to get to 3? 9 divided by 3 gives you 3. What did they do to the 6 to get to the 2? They divided by 3. So if you take 12 and you divide by 3, you should get a value of x, which is 4. I hope that makes sense. So that's why we would say x is equal to 4 centimeters. Okay, yeah. So the only answer that really makes sense here, yeah, because it's 4, right? Yeah, it's 4. Do you see why it's 4, guys? That's the answer that makes sense. X has to be 4. X has to be 4. Are we together there? Yeah, x is 4. No, I'm confused. Okay, so I'm just going to repeat this again. If you look at CE is 9 centimeters. And that 9 centimeters, all right, for that triangle, all right, if you look at the other triangle, you have 3 centimeters. So from 9, in order to get 3 from 9, what did they do to the 9? We divided the 9 by 3. Then if you look at 6, to get to 2, 6 divided by what gives you 2? 6 divided by 3 gives you 2. So that means with the 12, we'd have to do the same thing. 12 divided by what gives you 12 divided by the same number that we've been dividing by. We divided 6 by 3, we divided 9 by 3. We divided 6 by 3, we got 2. We divided 9 by 3, we got 3. We divide 12 by 3, then we should get, in the place of x, we should get 4 centimeters. So that's what same ratio would result in, you know. Yeah, so hopefully you get it now. Yeah, ED over AB, EC over AC, CE over EC over AC, and then DC over BC. All right, that's basically what makes sense. Yeah, ED over AB, AC, yeah, AC over EC, that's what makes sense, and then BC over DC. The thing is, if they make a mistake like this in a test, like they make a mistake in the exam question like this, right, then I suppose that eyebrow method here in this situation doesn't work because they've written the order incorrectly. The examiner has written the order of the letters of the triangle incorrectly. So what they would do is they would have to actually factor that in when they give you the marks. and maybe even taking out the question, because when they ask a question, the question must be fair, the question must make sense, the question must be legible, the question shouldn't be ambiguous, it shouldn't impose double meaning on the learner who's actually answering the question. It should actually just be clear. If it's not clear, then it's an unfair question, and if it's an unfair question, then they should actually take that into consideration. Okay, so what I'm saying is, do look if they've given you all the sides of the triangle except one. Okay, this is what I would suggest. Then make sure that you look at the two triangles, and then you try and establish the relationship that's there. AC and EC. All right, you can see that there's that ratio that works there. AC over EC. Okay, yeah, if you would do it intuitively, then you'd still get the mark, guys. Yeah, you definitely get the marks. Yeah, you definitely get the marks. So now you are saying ED over AB is equal to EC over AC is equal to DC over BC. All right, yeah, and then intuitively you would still get the marks. If you would do the question intuitively in the situation, I'd definitely give you the marks. There's no reason why they shouldn't. Okay, yeah. So, or you could say AB over ED, AC over EC is equal to BC over DC. Then obviously you choose this one. You can say AB there is actually X, ED is equal to 12, AC is equal to 3, and then lastly EC is equal to 9. Then it makes sense from there. It makes sense. Then you say X is equal to 3, you cross multiply. All right, cross multiplication. All right. Or sometimes they usually say you find the LCD and you multiply both sides by the LCD, but I cross multiply, okay, meaning you times both sides by 12 to get rid of the 12 in the denominator so that X can be isolated. So that cancels the 12 there. It leaves you with X over 1, and then if you times by 12 there, it's 3 times 12 over 9, which is 36 over 9. So that means X is equal to 4. For what? 4 centimeters. You see? And that basically solves that problem. Okay, so that's using the first two fractions. But this works as well if you use this first and the last. Okay, AB over ED equal to BC over DC. You would still get the same answer for this scenario. Okay, yeah, because I've actually looked at my triangles and I've made sure that the order or at least the situation that I'm in helps me to be able to get the same answer, whichever two ratios I actually order together and set up to solve for the unknown. Okay. All right, guys, I'm going to move on to the next question. I think we kind of fundamentally get the point, right? Determine the value of x and y from the diagram below if AB is parallel to DC. Okay, so that's a quadrilateral. You have the AB is parallel to DC, and they want the value of what? Of x and y. Where's x? There is x. Okay, but they've said if AB is parallel to DC. Okay, and 3x plus 15 is the entire angle there, as you can see it. 5x minus 40 degrees is also the entire angle, as you see it. Now, to be honest, guys, when I look at this diagram, I'm looking at it and I can see only one pair of parallel sides. It being just one pair of parallel sides, I almost feel like this particular diagram does not have enough information, to be honest. You know, look at y. Y is supposed to be a part of the diagonal I'm supposed to find. Okay, but what they should have done is actually tell me that both pairs of parallel sides are equal. So I should have, both pairs of sides are parallel. AB should be parallel to DC, and BC should also be parallel to AD, so that I can conclude that because this is a parallelogram, then I can basically use the idea of opposite angles being equal to then solve for x. So I would say 3x plus 15 is equal to 5x minus 40. And the reason why I would say that is opposite angles of a parallelogram. I mean, that's where fundamentally I would start. But like I said, they would have had to have told me first and foremost that the diagram below is a parallelogram. Okay, or at least, in the least, they should have told me that AB is parallel to DC and AD is parallel to BC, which they haven't done here. They've only told me of one pair of sides that are parallel. And I can't assume that this is a parallelogram. So this is one of those questions where I'm like, why did they not give us sufficient information? They should have, okay? And these are some of the things that when you don't have enough information, it makes it so difficult to answer the question. So I'm just going to recommend that they should have told us that ABCD is a parallelogram. I can't assume it is. I can't just say by looking at it, it is, but they should have explicitly told me that it is. Okay. What I'm saying is, yeah, you see the properties that, you see the thing is, you can't assume things about a diagram unless they are told to you. So what I'm saying is that for me, this question is one of those questions that I feel is unfair. Why? Because they have not provided adequate information. All right. Yeah. Had they said that ABCD is a parallelogram, now we would have been dealing with a totally different situation, which would make this situation a little bit more manageable. Okay. To say it's a quadrilateral, remember, it's to say it's a four-sided shape. All right. And a four-sided shape is just a shape with four sides. It could be any shape, you know. Yeah. So what I'm saying is that they need to provide more information. So let's just say they are saying here ABCD is a parallelogram. That takes care of the confusion. Now we know, okay, AB is parallel to DC, and we also know that AD is also parallel to BC, even if there are no writings or inscriptions that say that lines are parallel. But the minute they say it's a parallelogram, we know that all the properties for a parallelogram will apply. So what we would do then here is equate angle A and angle C. We'd say angle A is equal to angle C. Okay. And the reason why we would say angle A is equal to angle C is because these are opposite angles of a parallelogram. Okay. Once again, I'm using an acceptable reason from the acceptable reason document. Opposite angles of a parallelogram. Parallel lines with M means parallelogram, or palm if you want. I think some people allude to palm. And then all you do is you say 3x plus 15 degrees is equal to 5x minus 40. Then you solve. Okay, which makes sense. And then you put all your eggs in one basket. Divide both sides by a negative, obviously gives you a positive answer. So that will be x is equal to positive 55 degrees over 2. Okay. I think it's 22,5, right? No, sorry, 27,5. What am I saying? 27,5 degrees. That will be the answer. 27,5 degrees. Then they want y. They want y. Sorry. The y value there, that's a diagonal. Okay, y is equal to 16 centimeters. Why would they say y is equal to 16 centimeters? Diags of a parallelogram. Okay, remember that y, okay, indicates a diagonal. Okay, diagonals of a parallelogram, they bisect each other, we know that. So if that is 16 there, then it means y is also 16 centimeters. Okay, remember that 16 centimeters represents the length of a half of the diagonal. and then obviously the y would represent the other half. So that would basically lead us to conclude that y is equal to 16 centimeters. And the reason is because diagonals of a parallelogram, they bisect each other. Okay, or we can say diags of a parallelogram. I know that for short, we can say diagonal. That's just diagonals in short of a parallelogram. So we can say y is 16 centimeters. Diagonals are equal, we know that. Okay, guys, I think I'm going to, these are the concluding questions. I think we are left with these 4.7, and then I'll definitely leave you guys 4.6, 4.7, 4.8, and then I'm out of here. Sorry, guys. I'm sorry. I didn't mean to keep you up for so long. Sorry. Angle XYZ. Okay, XYZ is 100. You can see 100 degrees is there in the diagram. ZYP is 20 degrees. Determine the size of X and Y. Okay, so you can see XYZ is a what type of triangle? It is an isosceles triangle. Triangle what? X, Y, Z. You have 100 degrees there. You have an X there at the base of the triangle. But then you have equal sides, guys. Okay, those equal sides. Okay, we spoke about those equal sides. And we said something about the angles, and I suggested a reason that is not isosceles triangle. They want us to determine the size of X and Y. So we can start by finding the size of X, because it will be basic towards our calculation. Okay, thank you so much for remembering angles opposite equal sides. You're amazing. You're amazing. You are amazing for sure. So there we have it, guys. Okay, we can say OYZX, angle YZX is equal to X. Okay, because if that is X, that is also equal to X. YZX, the angle, is equal to X. What's the reason? Angles opposite equal sides. That's where we start. We fill in the missing angle. Then we can say X plus X. This X and this X plus the 100 is equal to 180 degrees. What's the reason? Interior angles of triangle. If you don't want to use that reason, you can use sum of angles in triangle. If you don't want that reason, you can say angle sum in triangle. This is one of 3 acceptable reasons you can use whenever you're dealing with the sum of the angles of a triangle. One of 3 in the acceptable reason document. One of these 3 are there. One of these 3 can be used. Okay, then we can solve 2x plus 100, 180 minus 100. Remember, we take the 100, we transpose, becomes negative 100. We divide both sides by 2. We get x is 40. I have 40. I have 40. I update my diagram. Then I think they wanted a y which was outside here, right? Very good, very good. I'm happy that you were right. Guys, very simple here. What is this called? These are angles on a straight line. You could get that angle using angles on a straight line. Or you could use, these are the interior opposite angles. They are equal to the exterior angle. So I'm just going to use that one because I haven't used it. Whenever we have a triangle and there's an angle outside that triangle that is in line with the side of the triangle, these 2 angles together added will give me the exterior angle of that triangle. So I can say here y, which is the exterior angle, is equal to 40 degrees plus 100. This 40 and this 100. Y, exterior angle of triangle. Don't forget that one. So that means y is equal to 140 degrees. Not to be forgotten. So sum of angles in a triangle is one aspect, but there's also exterior angle of a triangle, which is another aspect which I should never forget when it comes to solving certain problems that involve triangles. Did we get that one, guys? Was that one also easy to get? Or did that one take care of us? Okay, I'm glad it's easy for some people. That's great. Okay, let's look at this question. If BC is what? Is parallel. BC is parallel to VW. It's like I'm driving a Polo here. Angle A is 90 degrees, as you can see in the diagram. Okay. Determine the size of what? Of X and what? And Y. Determine the size of what? Of X and what? And Y. If BC is parallel to what? To VW. And I think they have an angle there that's exterior, which you can't see very well, but it's 141 degrees. The exterior angle where C is actually located. Very hard to see, but I want to suggest that it's 141 degrees. So they want us to find the value of what? Of X and what? And Y. So I'm sure you guys can see that it would be very safe to first find which angle. Yes, Y is equal to 141 minus 90. Can you see that, guys? 141 is the exterior angle. Why? Because it's in line with the side of the triangle. It's in line. The exterior angle is an angle formed in line with the side of the triangle. So it's the exterior. This is the two interior opposite, the Y and the 90. Not the X and the 90. We can't say the X and the 90 are the two interior opposite. It has to be the 90 and the Y, because the Y is where the line of the side of the triangle extends outside the triangle. So what we see there in the comment section, Miss Easy there, who has just told us, we can then say there Y. Okay, remember, the exterior angle is equal to the sum of the two interior opposite angles. The exterior, which is 141, is equal to the sum Y plus 90. Okay, so hopefully we understand that. So that is 141 exterior angle of triangle. So then we solve for Y. 141 minus 90 is equal to Y. What's 141 minus 90, guys? That's equal to 51 degrees. Thank you so much, Calvin. There it is, 51 degrees. We update our diagram, 51 degrees. What do we want now? X. What were we told? We were told that these two lines are parallel. So if these two lines are parallel, what do we know about these two angles? So Y is 51. What about X? X is equal to what, guys? Corresponding angles. Very good, very good. But remember, when we write that reason for corresponding angles, we need to make sure we write the right reason, the one that basically has power. Matla. Okay, so we say X is equal to Y, which is equal to 51 degrees, and we don't forget to state the parallel lines. We say corresp angles, then we state the lines that are parallel. VW is parallel to BC. Okay, we're done. We got Y using exterior angle of a triangle, using this angle plus that angle. Okay, we first got Y, which is equal to 51 degrees, because this entire triangle has this exterior angle, which is 141 degrees. This angle A and this angle B are the interior opposite angles. The sum of these two interior opposite angles gives me the exterior angle, which is 141, which is why I said 141 is equal to 90 plus 50, 90 plus y, sorry, y plus 90, reason exterior angle of triangle. Then I solved for y. I took 90 over to the other side. 141 minus 90, y is equal to 51. Okay, then after getting y is equal to 51 degrees, I then found y is 51. This y and this x have a relationship of corresponding angles. So therefore I said x is equal to y, which is equal to 51 degrees. What's the reason? Corresponding angles. VW is parallel to BC, because on top of this parallel line and on top of this other parallel line, we say these two angles are equal y, corresponding angles. Top is equal to top. Top is equal to top. Top speaks to top. They are equal. Corresponding angles, you state the lines that are parallel. Okay. If you are still lost, I don't know. Last question. Study the diagram below. I hope you have studied it. Classify A, B, C, D with at least one reason. Classify A, B, C, D with at least one reason. At least means one or more reason. When they say at least one, it means one or more. That's the minimum reason you can give is one, but you can also give more. Okay, so we must look at the mark allocation, and then if the mark allocation seems to say more marks, not just one mark, then we try and actually give more than one reason for why we are saying the certain quadrilateral is what we think it is. So when we classify this, what do we think, guys? Okay, I love this. Very true. Square. Diagonals bisect at 90 degrees. I love that. So ABCD is a square. And when we say diagonals bisect at 90, okay, that speaks to what? To your understanding of the properties of each shape. If you don't know the properties of each shape, then you are going to have an issue when it comes to finding or understanding the quadrilateral you are looking at. So you need to go back and do a thorough study of the quadrilaterals. And like I said, guys, I advise you, please make it a point that you post on your wall, in your room, somewhere, the properties of the quadrilateral, so that you can constantly see them, revise them, do them, understand them, so that they are in your mind. The reason there is 100%. Diagonals bisect at 90 degrees. That is the only feasible reason that makes sense. Diagonals bisect at 90 degrees for a classical square. So 100%, very good. The next question, 4.8.2, says determine the size of ADF. 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 Now, based on your conclusion about the type of shape it is, all right, and the fact that they've also have a angle that they seem to have identified, which is 45 degrees for angle E, I think there's something that can be done there to assist you in being able to find what needs to be found. ADF. So people are saying angle ADF is equal to 45 degrees. Okay. Why do we say so though? If ADF is 45 degrees, why are we saying that? remember, if it's a square, guys, then it means angle D is equal, angle ADC is equal to 90 degrees, right? Why? That's corner angles of a square. If it is a square, guys, it means angle ADC. Angle ADC is 90 degrees. Corner angles of a square, no doubt. Interior angles of a square, 90 degrees at the corner. Then, what about the diagonals of a square? The diagonals of a square, they bisect. What do? They bisect the corner angle. So that means angle ADF is equal to 45 degrees. Angle ADF is equal to 45 degrees. So this is what I would do. Angle ADC, first and foremost, is 90. Why? Corner angles of a square, that's why. Because remember, I identified this shape as being a square. Then secondly, ADF is equal to 45 degrees. Why? Diagonals bisect the corner angle. The diagonal of a square, or I would say diags of a square. Okay, and whoever is looking at this would understand why I am saying so. Okay, so if I may ask, was my answer accurate? Where was your answer? Angles opposite equal sides. Which part of angles opposite equal sides? Which angle were you saying is opposite that equal side? First and foremost, I need to understand. Angle F is 90. Okay, angle F is 90, very true. And then, oh, I see. Okay, but be careful, right? Please specify the actual angle in the appropriate order. Angle AFD. Remember, angle F, you know, you need to be specific about what angle F, because remember, F is the vertex. It's this point where these lines intersect. So if you want to be specific about this angle, you say angle AFD. Okay, then you can say that's 90, or you can specify angle DFC. Okay, so if you say that is 90, that's fine. Then you want to specify the specific angle here. So you are saying because these two sides are equal, you are saying the base, you are saying that the angles opposite these sides are equal. Therefore, I understand. I would say I would definitely mark you correctly if you were, because that's another part, that's another way. Then Kelvin, where did Kelvin speak? ABCD is a square. Yes, ABCD is a square, but then Kelvin, I don't see a reason. Okay, I don't understand, so I don't see the reason. Okay, guys, I think that brings us to the end of our live. Thank you so much. You guys were really, you held on for dear life. My goodness, can't believe you actually held on for this long. Who are my faithfuls? I'll see Prof when the live ends. I don't speak Tonga, guys. I'm actually ex-Hosa. I'm an ex-Hosa person. Yeah. So yeah, but like I said, thank you so much for joining. It was really good. I really appreciate the people that were here in good spirits. Please do come back with Super Not Angel. I tend to be a person who really loves it when learners are so avidly, they're hell-bent on making sure, or heaven-bent towards ensuring that they excel in their academics, especially, just doing well overall. So you guys, you enjoy writing your paper, have a blast of a time. I hope you really do well, and yeah, just give it your best. And please, when you are in the exam room and you are writing, think, apply your mind. Please, guys, apply your mind. Read and try and understand. Doesn't matter whether it's questions that you've seen before, questions you are seeing for the first time. Just apply your understanding that you have been, things that you've learned, and make sure that you do your calculations as accurately as you possibly can. Don't be careless. And don't overlook important information. Make sure you are reading thoroughly when you go through a question. Don't just coast by the question. Read it thoroughly and try to establish understanding, and then do your absolute best. God bless all of you. Bless you mightily. God bless you mightily. Father God, I just discharge your... Father God, I humbly come before you and want to thank you for this time that I've had with these learners to be able to do this live session covering straight line graphs, of course, how to find the equation of a straight line, how to draw a graph, whether that be using a table or using y-intercept method, how to establish the gradient of a straight line when the equation is in standard form. And many other various questions around your linear functions. Thank you, Father, for the manner in which they've conducted themselves whilst being here, them being proactive, them being able to actually really participate actively, and also just their generosity in the comments as well. Would you bless them as they write today, this morning? Give them the clarity of mind, give them the heart of excellence, give them a never say die attitude, give them absolute confidence, discipline, and may they perform at their utmost. Give them a good boost of morale, and give them confidence for days, and may they be given absolute grace as they write, power, strength, and may they be able to really just apply themselves as much as they can. That applies also to geometry, Father. Give them the analytical mind, and also just the mind to comprehend the questions as they come. Let them read with understanding, and may they apply their understanding to the various questions as they come across them. And may they be able to really just do well. Permeate them with a spirit of excellence. May they be granted that abundantly, above and beyond their own capacity. And Father God, will you also be able to deal with whatever issues may in some way stand in the way of their writing well? If there be anything in their minds and their hearts that may potentially disrupt them from being able to focus and concentrate, whether that be personal issues, home issues, issues that affect a person individually, would you be able, Father God, to disperse those? May you cast those away from their minds, and may you just give them, Father God, academic knowledge, understanding, concentration, and focus, and may they do well. May they be surprised, Father God, as they write this paper this time round. And this I pray for, Father God, in the mighty name of your Son, Jesus Christ, who loves us so much and who atoned for our sins so many years ago, whose sacrifice has so much efficacy in our lives right now. In the mighty name of Jesus Christ. Amen. Okay, guys, thank you so much. God bless all of you abundantly. You are blessed, highly favored. Abundance, excellence, everything. You receive it, you be it. And I pray as well that they don't lose anything that I have taught them, and anything that we may have reminded them of and which we have recapped. Sustain the knowledge, sustain the understanding in their hearts, and may they apply it fully and completely and absolutely. That's my prayer in the mighty name of Jesus Christ. Command anything that would want to oppose. I command it, that it may have no place, it may have no power, it may have no influence, it may have no commandeering effect in their lives. May it be silenced in the mighty name of Jesus Christ. Amen. Okay, God bless, guys. Thank you again. And definitely we'll run into each other again at some future time. Hopefully it will be under different circumstances, not just before you write, but hopefully also just consistently, so that we can build some good mathematical knowledge and academic mathematical knowledge understanding, so that it can affect and bless you for the future as well. Thank you guys, and good night.